Hello there, and welcome to the Sleepy Facts channel. Tonight, we'll drift together through the quiet expanse of our solar system, a gentle sea of planets, moons, and dust turning endlessly beneath the warm light of our star. In this space between day and dream, we'll explore not the loud explosions of cosmic history, but the stillness that remains after, the silence between orbits, the slow pulse of gravity, the tranquil certainty that even across billions of miles, everything moves in harmony. The solar system, vast though it seems, is a family, a collection of worlds born from the same cloud of gas and starlight, spinning together around a single glowing heart. When you look up at the night sky, you are seeing that family stretched across distance and time. The faint points of light are not separate things, but part of one enormous rhythm. Every planet, every moon, every grain of dust traces an invisible path shaped by gravity's patient hand. There are no edges in this cosmic dance, only gentle curves, repeating endlessly, softly, forever. Close your eyes and imagine floating at the edge of space. The sunlight here is clear and unfiltered, not golden like it appears from Earth, but pure white, radiant and weightless. There is no sound, no wind, no horizon. The planets turn in silence, each one wrapped in its own fragile atmosphere, each one carrying its own story of creation and change. In this vast stillness, you can feel the shape of time itself, not rushing, but flowing, calm and continuous. Our journey begins near the sun, that immense sphere of light that has burned for billions of years without pause. From a distance, it glows gently, like a lantern in deep water. Up close, it is a storm of energy and fire, its surface boiling with waves of plasma larger than entire continents. Yet even this violence has its serenity. The sun is constant. It has risen every day of your life, every day of all life that has ever been. Its light touches every world, every moon, every shadow in the system, binding them together in one endless exchange of warmth and motion. The sun does not burn as a fire burns. There is no smoke, no flame. Instead, deep within its core, atoms of hydrogen fuse into helium, releasing light as they merge. Millions of tons of matter are transformed into pure energy every second. Yet the star remains steady, as if it were breathing in perfect rhythm. The light you feel on your skin left the sun nearly 8 minutes ago, traveling across 93 million miles of space before arriving gently upon you. That light began in the heart of the sun more than 100,000 years earlier, slowly migrating through layers of radiant gas before escaping into open space. Every ray of sunlight carries that journey within it, the story of energy made visible, the whisper of nuclear fire turned into morning warmth. As the sun shines, its light reaches the first planet, Mercury, a small world scorched by proximity and frozen by shadow. Then Venus, cloaked in golden clouds, reflecting the sunlight so brilliantly that it outshines every star. Beyond that lies Earth, wrapped in air and water, where light meets life. Mars follows, red and waiting, its thin atmosphere holding memories of rivers long vanished. Between Mars and Jupiter stretches a field of rocky fragments, the asteroid belt leftovers from the solar system's birth, still orbiting like forgotten thoughts around the Sunday. Then come the giants. Jupiter, enormous and luminous, with its swirling storms and vast moons. Saturn, ringed and elegant, a sculpture of motion and light. Farther still, Uranus turns on its side, a pale blue world rolling through the dark, and Neptune, deep indigo and distant, whispering to the edges of the sun's reach. Beyond them, in the cold frontier of the Kuiper Belt, Pluto drifts, a small, frozen traveler that once was called a planet and still, in many hearts, remains one. Every world circles in silence, bound by the same law of gravity, the most patient of all forces. It does not rush or command. It simply waits, pulling gently, holding everything in its place. Even the smallest grain of dust in the sunlight follows its pull, looping endlessly through invisible paths. The planets do not fall into the sun because they are always falling, always moving sideways fast enough that the pull becomes a curve. In that balance of falling and flight, orbits are born perfect, eternal ellipses drawn by invisible hands. It is easy to imagine space as empty, but it is not. It hums quietly with energy. Streams of charged particles flow outward from the sun in all directions, a constant breeze called the solar wind. It fills the spaces between planets, shaping their skies and painting auroras upon their poles. When this wind touches Earth's magnetic field, it makes light dance green, and violet waves rippling across the night, the sky itself breathing in rhythm with the Sunday. Even at the edge of the solar system, billions of miles away, that wind still moves, carrying traces of our star into the interstellar dark. And out there, at the farthest frontier where the sun's influence fades, two small spacecraft drift onward, Voyager 1 and 2. They are our messengers, launched decades ago, now farther from home than any human creation has ever been. Their signals take more than 20 hours to reach us, faint whispers of data traveling through the cold. Each carries a golden record, a time capsule of sounds, music, and greetings from Earth. Somewhere beyond the heliopause, the border where the solar wind meets the interstellar medium, those records spin silently through the dark, waiting for ears that may never come. Yet the gesture itself, the act of sending, is enough. It is humanity's soft wave into eternity, a sign of curiosity and calm persistence written in gold. The solar system is not a violent place, not anymore. It was once wild, molten rock colliding, comets striking, moons forming from chaos. But now it drifts in peace. The planets move predictably, like gears in a cosmic clock. Moons rise and set, rings cast shadows. Seasons come and go even on distant worlds. Everything follows the same rhythm, the same quiet mathematics. If you could listen to the solar system the way you listen to a song, you would hear slow chords of gravity and motion repeating in endless, harmonious patterns. And within it all, Earth turns, the only world we know that sings with life. Our atmosphere filters the sunlight into blue. Our oceans carry the memory of ancient comets. The moonlight we see each night is sunlight reflected from a cratered mirror. Every wave, every heartbeat, every breath is connected to the slow turning of the planets. You are not separate from that motion. You are part of it, a living piece of the solar system, made of the same atoms as the stars, carried through space by the same gentle forces that move the moons and the dust. So, as you drift toward rest, remember this: you are already floating through the cosmos. Your body, your planet, your very breath, all part of the same quiet journey around the Sunday. Each night that passes is another rotation, each year another orbit. There is no need to hurry. The universe moves slowly, gracefully, perfectly. You belong to that rhythm. You are starlight, condensed and breathing, turning softly in the great cradle of the solar system. Let the thought settle gently in your mind that every sunrise, every glimmer of starlight, every whisper of wind across your skin is part of something vast and calm. The solar system is not far away. It is where you already are. And as you fall asleep, the planets will keep moving, the sun will keep shining, and the quiet hum of gravity will continue, as it always has, carrying us all through the stillness of space. The solar system's birth in dust and light. Long before there were planets or moons, before sunlight scattered across oceans, or clouds drifted through blue skies, there was only dust and darkness. The solar system began not as a collection of worlds, but as a cloud, an immense drifting nebula of hydrogen, helium, and the remnants of ancient stars that had died long before. Within that silent cloud lay everything that would one day become you, me, and every grain of sand on every shore. It was the aftermath of creation, the slow settling of cosmic debris into a new beginning. In the vast stillness of interstellar space, that cloud stretched for light years, its particles barely touching, each one suspended in a delicate balance between gravity and emptiness. And then, something shifted. Perhaps a nearby star exploded, sending a wave of energy rippling through the void. Perhaps the cloud simply reached a tipping point, its own gravity growing strong enough to pull itself inward. Whatever the cause, a slow collapse began. What had drifted aimlessly for eons started to fall toward its own center, drawn together by the quiet insistence of gravity. There was no explosion, no flash, only the gradual thickening of dust and gas spiraling ever inward. As it condensed, the cloud began to spin, turning faster and faster as its radius shrank. Just as a figure skater spins quicker when drawing in their arms, the young solar nebula whirled more rapidly, flattening into a disk of glowing material. At its heart, the densest region grew hotter and brighter until hydrogen atoms began to fuse the moment of ignition. The sun was born, a newborn star surrounded by a ring of shimmering matter. This disk was not smooth. Within it, tiny grains of silicate and ice began to collide, sticking together through static and chemistry. They gathered in clusters, clumping into pebbles, then boulders, and eventually into planetesimals, small, irregular bodies that roamed the disk like early seeds of worlds. Each impact generated heat, fusing matter tighter, drawing it into orbits defined by chance and motion. Over millions of years, these planetesimals grew into protoplanets, embryonic planets, each one competing for material, sweeping their paths clean of smaller debris. Closer to the newborn sun, the heat was too fierce for volatile materials to survive. Only metals and rocks could endure, and so the inner planets took shape: Mercury, Venus, Earth, and Mars. Small, dense, and solid. Farther out, beyond a boundary called the frost line, temperatures dropped enough for ice and gas to condense. Here, enormous worlds began to form: Jupiter and Saturn, their vast gravities pulling in hydrogen and helium from the surrounding cloud. Even farther still, Uranus and Neptune gathered methane and ice, becoming the pale giants at the edge of light. Between these realms, gravity sculpted everything. Some regions became stable, others chaotic. Where planets grew large, their gravity scattered debris into new orbits. Some of this material coalesced into moons, companions born from collisions or captured from the drifting dark. Other fragments were flung into deep space or cast into distant, frozen orbits that would one day form the Kuiper Belt and Oort cloud. In the silence of the void, a system of balance slowly emerged: 8 planets, countless moons, and a thin haze of comets and asteroids, all turning around a single star. It is hard to imagine the timescale of such a creation. From the first gathering of dust to the final clearing of debris, the process spanned tens of millions of years, long enough for mountains to rise and vanish, had Earth existed then. Yet in cosmic time, it was a heartbeat, a single breath in the long story of the universe. What began as chaos settled into order. What was formless became familiar. Gravity, that invisible sculptor, had drawn harmony from nothingness. Even now, the remnants of that birth remain. Every meteor that streaks across the night sky is a fragment from those first days, a piece of the original disk, unchanged for billions of years. When it burns in our atmosphere, you are watching history ignite, a brief flicker of light, older than life itself. The same minerals that formed the rocky planets can be found in those meteors. Silicates, iron, carbon, the building blocks of worlds. The water in your body may once have frozen as ice in the outer nebula, carried inward by comets that rained upon a young Earth, delivering oceans in their wake. The sun, too, remembers. Deep within its core, hydrogen still fuses into helium as it did when it first lit the darkness. Each second, the sun converts 4 million tons of matter into light, a quiet, ceaseless transformation that began at the dawn of the solar system. That light spills outward, crossing the cold void, touching every planet, moon, and grain of dust still bound by its gravity. It is the same light that once warmed the newborn Earth, and the same light that now filters through your window, painting morning across your room. In the calm of night, it's easy to forget that everything solid, every mountain, every drop of rain, every cell in your body is part of that ancient process. The calcium in your bones was forged in dying stars that lived long before our sun existed. The iron in your blood was born in supernovae, flung across galaxies, gathered again by gravity into the cloud that became our solar system. You are, in the most literal sense, made from the dust of that nebulous stardust shaped by time into thought. The atoms that once drifted through interstellar darkness now sit quietly within you, breathing, dreaming, remembering. When the sun first rose over the forming Earth, there were no eyes to see it, no oceans yet to reflect its light. The planet was molten, its surface glowing red, scarred by endless impacts. But already, the seeds of life waited water carried from icy comets, carbon molecules falling through the air. The same sunlight that fueled the early chemistry of life still falls upon us today. The same warmth that stirred the first oceans still touches our faces when we step outside. Every sunrise is an echo of that first ignition, that first spark of fusion that turned darkness into day. As you imagine that ancient dawn, let your thoughts drift like the dust that began it all. See it swirling slowly, gathering into rings, into planets, into moons. Feel the vast patience of time, the way nature builds without hurry, shaping entire worlds from silence and motion. Nothing was wasted in that process. Every collision, every orbit, every speck of dust served its purpose. And in the end, from chaos came balance. If you could float above it all, watching the solar system form, you would see beauty beyond description. The sun, glowing like a newborn ember, the disk around it shimmering with streaks of light and shadow, clumps of matter drifting together, glowing faintly as they collided, the beginnings of planets, glowing red with heat. You would see Jupiter forming first, its gravity sweeping the disk clean, then Saturn following, its rings beginning to shimmer in the starlight. You would see Earth cooling, its surface darkening as oceans condensed from vapor, the first clouds forming above molten seas. And beyond, in the outer dark, small, icy bodies gathering the beginnings of Pluto and its kin, the frozen remnants of creation waiting in silence. That is how it all began, quietly, elegantly, without chaos or noise. The solar system is not a miracle in the sense of chance, but in the sense of balance. It was always possible that such order could arise, yet it remains astonishing that it did. From dust and darkness came light and form. From nothingness came the pattern of orbits that continues to this moment. And through it all, gravity whispers, holding everything in its slow embrace. The same gravity that drew the first particles together now keeps the planets turning, the moons circling, the comets returning after millennia. It is the universe's softest voice, one that never shouts, but never stops. The solar system is its song, played in endless repetition across billions of years. As you rest now, you are part of that same ancient rhythm, The Earth turns beneath you, orbiting the sun that was born from dust and light. Every second carries you through that cosmic dance. The stars above are older than memory, yet they shine upon you now, just as they once shone upon the newborn worlds. You are not apart from the solar system. You are one of its quiet results. Stardust gathered, shaped, and breathing softly in the dark. To the sun, a continuous dawn. The sun is not simply a star. It is a rhythm, an endless breath of light that has never once paused in more than 4.5 billion years. Every sunrise you have ever seen, every glint upon the ocean or shimmer through the trees, is the echo of this quiet, burning heart of our solar system. It is the keeper of warmth, the reason rivers flow and winds move, the silent metronome by which all life on Earth keeps time. Without the sun, there would be no seasons, no color, no sound, only stillness. Yet the sun is far from still. It is a sphere of perpetual creation, fusing elements together in a furnace of unimaginable energy, all while maintaining a serenity that defies comprehension. To look at the sun from afar is to see perfection disguised as simplicity. Its glow is soft from this distance, filtered by the veil of air that surrounds our planet. But if you could drift closer, past the warmth and into the heart of its brilliance, you would find a world of motion, rivers of plasma rising and falling in slow, silent loops, magnetic fields twisting through waves of incandescent gas, and flares of light bursting like the sighs of a restless god. And yet, for all this activity, there is peace in its purpose. Every movement, every flare, every heartbeat of fusion serves a single function: to transform matter into light. At the sun's core, where the temperature surpasses 15 million degrees, hydrogen atoms move with such speed and density that they collide and merge into helium. In that instant, a fraction of their mass vanishes, transformed into pure energy. That energy, created by the loss of just a tiny piece of matter, is released as photons, the smallest quanta of light. Each photon begins a long, meandering journey outward. It will take more than 100,000 years to travel from the sun's core to its surface, bouncing endlessly among atoms in a slow diffusion that turns chaos into radiance. Only when it finally reaches open space does that light travel freely, crossing 93 million miles to reach the waiting surface of Earth in a mere 8 minutes. The light that falls on your face this morning was born in an age when mammoths still walked the tundra. The sunlight that now warms the oceans began as a spark deep within the sun before humankind even dreamed of language. The sun is not only a source of energy, it is a time machine, a living archive of the universe's persistence. Every beam of light is a message sent long ago, reminding us that even in the heart of fire, patience reigns supreme. From our perspective, the sun seems eternal and unchanging, but its surface is alive. There, plasma, a fluid of charged particles, boils and churns in vast, looping motions. Granules the size of continents shimmer and fade every few minutes, rising and falling like slow waves on a golden sea. Dark patches called sunspots mark areas where magnetic fields twist tightly, cooling the surface slightly and creating contrast within the glow. These regions often erupt with sudden storms of light and energy, solar flares that fling radiation and charged particles into space, traveling across the solar system in invisible gusts. When those gusts reach Earth, they stir our planet's magnetic shield, creating ripples that cascade into the atmosphere. The result is one of the most beautiful phenomena in nature, the aurora. Curtains of green and violet shimmer across polar skies, tracing the shape of Earth's magnetic field in waves of light. What you see as a tranquil dance in the night sky is, in truth, the echo of solar storms, sunlight turned to color, energy turned to art. Yet for all its power, the sun is remarkably stable. It has maintained a delicate balance between gravity and pressure for billions of years. Gravity tries to pull it inward, while the heat of fusion pushes outward. And between these two forces lies perfect equilibrium. This balance is not static, but dynamic. A constant negotiation that keeps the sun neither collapsing nor exploding. It is the quiet strength of symmetry, the same principle that holds the planets in orbit, the same principle that lets a candle burn steadily in still air. Our ancestors once saw the sun as a god. They built temples aligned with its rising, carved symbols to honor its warmth, and imagined it as the chariot of divine fire crossing the sky. But science revealed something even more wondrous. The sun does not need divinity to be miraculous. It is a natural consequence of the universe's laws, and those laws are themselves breathtaking. To know that such light comes from the fusion of simple hydrogen, the most common element in existence, is to realize that beauty can arise from the humblest of beginnings. Out of simplicity, complexity unfolds. Out of a single element, life becomes possible. When sunlight touches Earth, it does more than warm its surface. It awakens chemistry. In plants, photons strike green pigments called chlorophyll, triggering the transformation of carbon dioxide and water into sugar, the process of photosynthesis. Every tree, every leaf of grass, every breath of oxygen in your lungs exists because of that exchange. The sun is not just a star in the sky. It is the first artist of life, painting the planet with energy that flows through every living thing. Even your heartbeat is powered, indirectly, by sunlight absorbed long ago. The food you eat, the air you breathe, the warmth you feel, all of it is sunlight transformed and shared. Despite its immense energy, the sun is gentle from where we stand. Its light falls evenly, filtered by the thin veil of air and cloud. In the early morning, it glows amber, scattering softly through moisture and dust. By noon, it becomes pure and white, illuminating everything without judgment. At dusk, it bends through thicker air again, stretching into long wavelengths that paint the sky in fire and rose. But those colors are illusions of distance, tricks of atmosphere and scattering. The sun itself does not change. It shines with quiet consistency, indifferent to the moments it inspires, yet inseparable from them. Deep within, however, the sun is changing slowly. Every second, it consumes millions of tons of hydrogen, turning it into helium. Though this seems enormous, the sun has such an abundance of fuel that it will continue shining for another 5 billion years before its balance begins to waver. When that time comes, the sun will expand into a red giant, swallowing Mercury and Venus, perhaps even brushing the edges of Earth's orbit. Its outer layers will drift away into space, forming a glowing shell of gas that will shine briefly as a nebula before fading. The core will remain a white dwarf, no larger than our planet, glowing faintly with the last echoes of its heat. Even then, it will take trillions of years to cool completely. The sun's death will not be an explosion, but a quiet dimming, a gradual return to darkness. But that is far beyond our time, far beyond even the memory of our species. For now, the sun continues its ancient work. Each ray of light a continuation of the same act of creation that began long before Earth was born. It burns not out of anger or passion, but out of balance and equilibrium between collapse and expansion, between silence and brilliance. In that balance lies its serenity. If you were to drift far enough into space, past the reach of Earth's orbit, and turn back toward the sun, you would see something extraordinary. Against the infinite black, it would appear as a golden coin of fire, small but fierce, surrounded by a halo of pale light that fades gently into the dark. Around it, the planets would turn in invisible paths, each one held by the same gravity, each one bathed in the same warmth. From that distance, the sun would not seem overpowering but peaceful, a beacon in the void, steady, patient, eternal. The sun's light is not simply energy, it is connection. It links every world in the solar system, every orbit and every shadow. It is the thread that binds us to our cosmic family, the pulse that keeps time in the vastness of space. And in that connection lies comfort, for as long as the sun burns, life on Earth will have its mornings. The warmth on your skin, the golden hue on the horizon, the soft radiance that fills the air, these are not fleeting moments. They are fragments of the same continuous dawn, a light that has been shining since before life began and will shine long after we are gone. So as you breathe now, beneath that steady glow, remember that you are already part of the sun's story. Every heartbeat, every breath, every flicker of thought is powered by its patient fire. You are sunlight slowed down, turned into living form, dreaming beneath the very star that made you. And as you close your eyes and drift towards sleep, know that the same warmth that rises over mountains and oceans will rise again tomorrow, constant, calm, and eternal. The sun will keep shining, as it always has, carrying you gently through another quiet revolution of the endless, glowing day. 3. Mercury, the planet of extremes. If you were to stand on the surface of Mercury, you would see the sun rise and set twice in a single day. The sky would be black, not blue, and the sun would appear more than twice as large as it does from Earth, blazing with a brightness that could strip the landscape of all color. The airless silence would press against you, and the ground beneath your feet would shimmer with heat so intense it could melt metal. And yet, if you waited long enough for night to fall, the temperature would plunge so deeply that even the hardest steel would freeze. This is Mercury, the smallest planet, the closest to the sun, and perhaps the most extreme world in the solar system. Mercury has no air to soften sunlight or scatter color. It has no clouds, no wind, and no true atmosphere to speak of. Only a thin trace of gas, born from atoms escaping the surface, drifts above it. The planet's silence is absolute. There is no rustle of dust, no sigh of breeze. Even sound itself has nowhere to travel. It is a world of pure stillness, a relic of the solar system's earliest days, preserved almost exactly as it was billions of years ago. When sunlight reaches Mercury, there is nothing to stop it. The planet absorbs the full brilliance of the sun, baking one side to more than 430 degrees Celsius. Yet, just beyond the horizon, where night begins, the temperature drops to nearly -180. It is a world split between fire and frost, day and night existing as opposites only a few hundred kilometers apart. The difference is not gradual, it is abrupt, a sharp boundary of shadow that creeps across the ground as the planet slowly rotates. To stand at that border would be to see sunrise and sunset at once, half of the landscape glowing white-hot, the other half lost in eternal dark. Mercury spins slowly compared to its orbit. It completes one full rotation every 59 Earth days, but it circles the sun in just 88. Because of this strange rhythm, a single day from one sunrise to the next lasts nearly 2 Mercury years. The sun does not move across the sky as it does on Earth. Instead, it drifts upward, pauses, and then slowly slides backward before resuming its path again. To the observer, time itself would seem to waver. Day and night unfold in a dance of impossible pacing. The sky brightens and dims, the shadows stretch and twist, and then, once more, the sun retreats into darkness. The surface of Mercury is ancient, older than any landscape on Earth. It is covered in scars from countless impacts, craters, ridges, and plains of solidified lava that tell the story of its violent youth. When the solar system was young, debris still filled the sun's orbit. Asteroids and comets rained down for millions of years, and Mercury, so close to the center, bore the brunt of their fury. Some of the craters stretch hundreds of kilometers across. One, called Caloris Basin, is so vast that the curvature of the planet itself cannot contain it. The impact that formed it must have shaken the entire world, sending ripples through the crust that froze into ridges on the far side. Even now, billions of years later, those ripples remain, carved into the rock like the wrinkles of a scar long healed. Yet for all its violence, Mercury endures. It has no weather to erode its history, no oceans to wash its surface smooth. Every crater, every ridge, every scar remains, preserved in silence. The planet's appearance today is almost exactly as it was when the first planets formed. In this way, Mercury is a time capsule, a fossil of the solar system's beginning, untouched by the changes that shaped other worlds. The planet's small size has always puzzled astronomers. It is dense, composed mostly of metal, with an iron core that makes up nearly 3/4 of its diameter. This proportion is unlike any other planet. Some scientists believe that Mercury was once larger, but long ago, a massive collision stripped away much of its outer layer, leaving only the heavy heart behind. Others think that the early sun's fierce heat may have evaporated lighter materials before the planet could fully form. Whatever the cause, Mercury remains as a remnant, a metallic ember circling close to the furnace that forged it. Despite its proximity to the Sun, Mercury experiences something counterintuitive. It is not the hottest planet. That title belongs to Venus, whose thick atmosphere traps heat like a blanket. Mercury, by contrast, cannot hold warmth at all. Its lack of air allows the heat to escape immediately into space once night falls, leaving its surface frozen solid. The extremes of its climate are not born from temperature alone, but from contrast, the endless oscillation between burning and freezing, light and shadow. It is a planet that never finds equilibrium, always caught between two opposing states. On its surface, the Sun dominates the horizon, immense and brilliant. It is said that if you stood within one of Mercury's deep craters near the poles, you might never see the Sun at all, only the faint reflection of light on distant peaks. These polar craters, untouched by sunlight for billions of years, are among the coldest places in the solar system. In their eternal shadow, spacecraft have detected something unexpected: water ice, frozen, ancient, and preserved in a world where daytime heat could melt rock. These deposits likely arrived on comets long ago and have remained untouched since. In the paradox of Mercury, even at the doorstep of the Sun, ice endures. Mercury's thin exosphere, a whisper of particles knocked loose by solar radiation, creates a kind of invisible veil around it. These particles escape easily, drifting away into space, only to be replaced by new ones ejected from the surface. It is not an atmosphere in the traditional sense, but a delicate exchange between rock and sunlight. The planet is constantly losing and regaining its skin of atoms, shedding itself grain by grain into the void. Over eons, this process has subtly reshaped its surface, polishing some regions and darkening others, as if the Sun itself were an artist slowly refining its work. Viewed from afar, Mercury moves like a bead of light around the Sun, a bright spark appearing just before dawn or just after sunset. To ancient observers, it was two different stars, one called the morning star and one called the evening star, until they realized both belonged to the same world. Even now, Mercury is difficult to see with the naked eye, always lost in the glow of the Sunday. It is the shyest of planets, revealing itself only briefly, as if reminding us that even the closest worlds keep their distance. Spacecraft have visited Mercury only a handful of times. The first, Mariner 10, passed by in the 1,970 seconds, capturing glimpses of a cratered desert that looked eerily like our moon. Decades later, the Messenger mission orbited Mercury for 4 years, mapping its surface in detail and uncovering new mysteries unexpected hollows where volatile materials had vanished, magnetic fields flickering with strange variations, and hints of chemical complexity beneath its desolate face. These discoveries painted Mercury not as a barren husk, but as a world of quiet activity, still evolving in subtle ways beneath its ancient skin. To imagine Mercury is to imagine contrast. It is a world where silence and heat coexist, where sunlight is both life-giving and destructive, where day and night are separated, not by time, but by survival. And yet, for all its extremes, there is something soothing about its constancy. Mercury does not change much. It has no seasons, no weather, no life or chaos. It simply turns, endlessly, in the soft pull of gravity, orbiting its star as it has done since the beginning. It is the first planet to greet the sun each morning, the herald of light in the cosmic dawn. If you could listen to Mercury, if sound could travel through its vacuum, you would hear nothing. Only the faint hum of solar wind sweeping past. Only the vibration of photons striking rock. In that silence lies its peace. Mercury's story is one of endurance, of balance between extremes. It reminds us that even in the most hostile places, beauty can exist not in comfort, but in persistence. So as you rest, think of that small world circling closest to the sun, half in shadow, half in flame, moving through the void with unhurried grace. Its days are long, its nights eternal, and yet it never falters in its orbit. The same sunlight that warms you now falls upon its barren plains, glinting off ancient craters, spilling across peaks where ice hides in darkness. Mercury turns, slowly, silently, endlessly, a small, steadfast traveler in the glowing heart of creation, where every sunrise is eternal and every night infinite. For Venus, a mirror of what Earth could have been. If Earth is a garden, then Venus is its reflection. Seen through heat and haze, a world that looks familiar from afar, yet hides a reality so alien that even our imaginations struggle to hold it. When you look at Venus in the evening sky, it appears as a bright pearl suspended in twilight, the most radiant object after the moon. To the naked eye, it seems calm and beautiful, a symbol of serenity that has inspired poets, dreamers, and ancient astronomers for millennia. But beneath its luminous clouds lies a planet of fire, a place where mountains glow with heat, and the air itself is heavy enough to crush metal. Venus is beauty wrapped around chaos, a mirror that shows what Earth might have become under different circumstances. For centuries, people thought Venus was a twin to Earth. They are almost the same size, nearly the same mass, and both stand within the sun's warm zone, where liquid water could once have flowed. Early astronomers imagined lush jungles beneath its clouds, oceans of mist shimmering in perpetual dawn. Through telescopes, its surface was hidden, glowing softly like marble under light. But when our machines finally reached it, the truth was unveiled. The clouds of Venus are not made of water, but of sulfuric acid. And beneath them lies a landscape hotter than any furnace, a planet that burns at over 460 degrees Celsius, day and night. The atmosphere of Venus is so thick that the surface pressure is more than 90 times that of Earth, the same as standing nearly a kilometer beneath the ocean. A spacecraft descending through that crushing air would feel its metal skin warp and bend under the weight. The air itself is toxic, composed mostly of carbon dioxide, with only traces of nitrogen and clouds laced with corrosive acid. Yet despite this oppressive veil, sunlight still filters through, its energy trapped by the dense gases that wrap the planet like an enormous thermal blanket. The result is a runaway greenhouse effect, an endless feedback loop of heat that has turned Venus into the hottest world in the solar system. It wasn't always this way. Billions of years ago, Venus may have been temperate, with oceans and clouds much like our own. Models of its early atmosphere suggest that for a time, It could have harbored rain, rivers, and perhaps even life. But as the sun grew slightly brighter with age, the delicate balance began to shift. The oceans warmed, releasing more water vapor into the air, which trapped even more heat. Slowly, the planet's surface boiled dry. Water, once the great regulator of climate, vanished into the sky, where ultraviolet light from the sun split it apart, allowing hydrogen to escape into space. Without oceans to absorb carbon dioxide, the gas built up unchecked, thickening the air until it became a furnace. What had once been a sibling of Earth transformed into a cautionary vision, a greenhouse world gone too far. If you could stand on the surface of Venus, you would see a dim orange sky, hazy and close. The sun would appear only as a faint glow through thick clouds, its light diffused into endless dusk. The ground beneath your feet would be made of volcanic rock, cracked and scorched, stretching in all directions. Mountains rise higher than Everest here, their slopes carved not by wind or rain, but by lava that once flowed like rivers. The planet's surface is young, in geological terms only a few 100 million years old, suggesting that much of it has been resurfaced by vast volcanic eruptions. Entire continents of molten rock once welled up from below, erasing craters and reshaping the land. The air would shimmer with heat, and each breath, if you could take one, would be poison. Venus turns slowly, so slowly, that its day is longer than its year. One rotation takes 243 Earth days, while it orbits the Sun in just 225. Stranger still, it spins in the opposite direction to every other major planet. On Venus, the Sun rises in the west and sets in the east, though the clouds are so thick that no one standing below would ever see it. This backward spin, this inversion of time and motion, makes the planet seem almost willful, as if it had chosen to defy the rules of the solar system itself. Above the crushing atmosphere, the winds tell another story. At high altitudes, the air races around the planet, at speeds faster than any hurricane on Earth, circling the globe in only 4 days. These winds move 60 times faster than the planet's rotation, dragging the upper clouds into spirals and waves that can be seen even from millions of miles away. From orbit, Venus appears alive with motion, an ever-changing dance of pale gold and amber that hides the stillness of the world below. The clouds that cover Venus are a mystery in their own right. They are layered in thick, swirling sheets of sulfuric acid, illuminated by sunlight that scatters and refracts, creating patterns that seem to shift and breathe. The upper atmosphere, though hostile, is cooler and less pressurized, leading some scientists to imagine that microbial life could drift there, suspended in droplets of acid and vapor, protected from the inferno below. No one knows for certain. In that delicate twilight above the clouds, temperatures and pressures are similar to those on Earth's surface, a rare balance in a place otherwise defined by extremes. The surface of Venus remains hidden from the naked eye, but radar has unveiled its form. Vast plains stretch across most of the planet, broken by mountain ranges and volcanic domes that rise like islands in a sea of stone. Some of these volcanoes may still be active, releasing slow streams of molten rock that vanish beneath the clouds. In recent years, subtle changes in heat patterns have hinted that Venus is not a dead world, but one that still breathes, its crust shifting and cracking beneath the weight of its atmosphere. Even in silence, it may still be alive. There is something hauntingly beautiful about Venus's permanence. While Earth changes constantly, oceans moving, continents drifting, life reshaping its surface, Venus endures. Its storms never weaken. Its temperature never drops. Every hour is the same as the one before, a world locked in eternal equilibrium. To visit Venus would be to step into a place without variation, a landscape preserved in perpetual tension between light and shadow, creation and destruction. It is a reminder that balance is not always gentle. Sometimes it is fierce, maintained by heat and pressure rather than harmony. And yet, when seen from afar, none of this turmoil is visible. From space, Venus glows with serene beauty. Its clouds reflect sunlight with perfect efficiency, making it one of the brightest objects in the sky. On Earth, we see it most clearly just before dawn or just after sunset, when the atmosphere softens its light into something delicate and pure. For millennia, it has been called the morning star, the evening star, the bringer of light. Ancient civilizations built myths around its motion, seeing in its appearance, disappearance, the promise of renewal. They could not know that the same brilliance was born from fire and acid, that the calm glow hid a world of storms. Still, there is comfort in that contradiction. Venus teaches us that beauty can exist even in the most inhospitable places. Its radiance reaches across space to remind us that light and heat are inseparable, that creation and destruction are parts of the same cosmic cycle. In some distant future, when the sun grows larger and Earth's oceans begin to steam away, our planet may follow Venus into that same transformation, a second bright star in the evening sky, a warning written in light. For now, Venus remains our sister in the void, distant but familiar, its path around the sun intertwined with ours. When you see it hanging above the horizon, glowing through twilight, remember that you are looking at a world where mountains melt, where the air itself shines, where time runs backward. Yet, despite its extremes, it remains one of the most peaceful sights in the heavens, a quiet beacon at dusk, a perfect illusion of calm. As you close your eyes tonight, picture Venus suspended in its orbit, turning slowly beneath its golden clouds. The same sunlight that warms your skin is reflected from its surface, scattered and softened by haze. It glows not in defiance but in endurance, a light born from fire, a mirror of what might have been, drifting gracefully through the endless dark. 5. Earth, the quiet balance. There is a calmness in the sight of Earth that no other world quite possesses. Seen from afar, it glows with a soft blue hue, wrapped in swirls of white and hints of green and brown, a fragile orb adrift in the quiet sea of space. It does not blaze with the brilliance of the sun, nor shine with the icy light of distant moons. It simply glows, softly, steadily, like a lantern in the dark. Every planet has its beauty, but Earth's is different. It is not static or sculpted by fire alone. It breathes. It moves. It sings with the rhythm of water and wind and life. It is balance, made visible, the delicate harmony of chaos and calm. Earth was not always so peaceful. In its infancy, it was a molten sphere, constantly struck by debris left over from the solar system's creation. Volcanoes erupted ceaselessly, filling the air with gas and ash. Lightning flickered across endless storms, and oceans of lava stretched from horizon to horizon. But through the long patience of time, this fury cooled into form. Gases thickened into air, molten rock solidified into crust, and somewhere within that restless surface, the first drops of liquid water condensed and fell. From that moment onward, Earth began its transformation into the world we know. A world defined not by stillness, but by the quiet motion of equilibrium. The presence of water made all the difference. Oceans gathered in the low places, vast and blue, reflecting the newborn Sunday. They became mirrors and cradles all at once. Mirrors to the sky above and cradles for the chemistry of life. Within their depths, molecules drifted and met, forming chains and patterns that would eventually learn to replicate, to evolve, and to dream. The Earth became more than rock and air. It became a system of endless circulation, where every drop, every gust, every heartbeat played a part. It is easy to forget how improbable this balance is. The Earth orbits the Sun at just the right distance for water to remain liquid, not too close, where it would boil away, and not too far, where it would freeze. This narrow band is called the habitable zone, and our world sits near its heart. The atmosphere, too, maintains a perfect balance, thick enough to trap warmth, thin enough to let sunlight reach the ground. Even the tilt of the planet, 23.5 degrees, gives us seasons, the gentle turning of climates that allows life to adapt, rest, and renew. Every variable, from orbit to inclination, from gravity to chemistry, aligns as if tuned for harmony. But this harmony is not a static thing. It is a living tension between forces that never rest. The sun's light warms the air, causing it to rise. The rising air cools, condenses, and falls again as rain. The oceans absorb heat and release it, driving currents that circle the globe. The molten rock beneath the crust flows in slow convection, pushing continents apart and pulling them together again. Mountains rise, crumble, and are carried away by rivers, their dust settling on the ocean floor where new land will one day be born. In every moment, destruction and creation occur side by side, each necessary for the other's existence. Even the air you breathe is a product of this balance. Billions of years ago, Earth's skies were suffused with carbon dioxide and methane. Then came the first photosynthetic organisms, tiny cells floating in shallow seas, using sunlight to split water and release oxygen. They filled the atmosphere with this invisible gift, slowly transforming a hostile world into one capable of supporting complex life. The oxygen we inhale today, the same that fuels our bodies, is ancient sunlight preserved in the chemistry of air. Every breath you take connects you to that lineage of transformation. Earth's magnetic field shields us from the fury of the Sunday. Without it, the solar wind would strip away the atmosphere molecule by molecule, just as it did to Mars long ago. Deep within the planet's core, molten iron moves and churns, generating this invisible shield. Though we never feel it directly, it protects every living thing, deflecting radiation, preserving the fragile skin of air that holds our weather, our oceans, and our breath. The auroras that shimmer near the poles are the visible expression of this defense, curtains of color painted where the solar wind meets the magnetic veil. In them, the invisible becomes visible, a gentle reminder of the unseen guardianship that surrounds us. Life on Earth is a story of constant adaptation, from the simplest microbes to the vast forests, from coral reefs to the wings of birds. Every form of life adjusts to the planet's rhythm. Plants grow toward light, animals follow the migrations of seasons, and even the tides pulse with the pull of the moon. Everything moves in patterns, some fast, some slow, but all connected. To stand in a forest at dusk or by the shore at dawn is to feel that pattern flowing through you. The air shifts with temperature, the light bends through water, and your heartbeat falls into the same quiet cadence that guides the earth itself. The diversity of life that fills our world is staggering. From the frozen poles to the equator's heat, every corner of the planet finds a way to live. Some creatures thrive in boiling springs, others in the blackness of ocean trenches. Forests breathe carbon dioxide by day and exhale oxygen by night. Fungi weave unseen networks beneath the soil, exchanging nutrients among roots like silent traders. Even decay has purpose. When one life ends, its elements return to the cycle, feeding the next generation. There is no waste in nature, only transformation. Above it all, the atmosphere acts like a vast, transparent ocean. It scatters blue light, giving the sky its color. It bends sound, carries clouds, and glows faintly at the edge of dawn. From space, it appears as a thin blue halo around the planet, a veil so delicate that it could vanish with the smallest imbalance, yet strong enough to hold storms, seasons, and the breath of every living thing. When astronauts see Earth from orbit, They often speak of this fragility. They describe the line of air as something impossibly thin, a reminder that all of life exists within a layer no thicker than paint upon a sphere of rock. Earth is not perfect. Its surface trembles with earthquakes. Its skies roar with hurricanes. Its climate shifts through ice ages and droughts. But even these disruptions are part of the larger rhythm. Plate tectonics recycle the crust. Volcanoes release gases that renew the atmosphere, and storms redistribute heat and water across continents. The system adjusts itself constantly, seeking equilibrium like a pendulum swinging between extremes. The result is not stillness, but resilience, the ability to bend without breaking, to evolve rather than vanish. And then there is you, humanity, the newest voice in the Earth's long song, capable of reflection, of curiosity, of awareness. You are part of the balance, not apart from it. The oxygen in your lungs once flowed through leaves. The carbon in your body once drifted in the air. The water in your blood fell as rain centuries ago. Every cell of your being is recycled from the planet's memory. When you exhale, your breath becomes part of the sky. When you walk, the ground accepts you as something it already knows. You are Earth remembering itself, conscious, fragile, and luminous. At night, when you look up and see the moon shining above, remember that it, too, is part of Earth's story. It was born from the planet's own flesh, thrown into orbit by a colossal impact in the deep past. Its presence steadies Earth's tilt, moderates the tides, and keeps our seasons regular. It is the counterbalance to Earth's motion, the silent companion that turns with us through the void. The pull between the two bodies creates the tides, that endless breathing of the oceans that reminds us of connection even across distance. If you could listen to Earth from space, you might hear no sound, only a low hum of electromagnetic whispers. But if you could feel it, you would sense movement everywhere. Waves crossing oceans, wind brushing treetops, molten rock turning beneath the crust. All of it together forms the planet's quiet heartbeat, steady and patient. And so, as you rest, imagine that heartbeat. Imagine the planet turning gently beneath a veil of air, its oceans shifting under moonlight, its continents breathing through forests and storms. You are lying within that rhythm, carried through space by the same forces that hold the planets in their orbits. The sunlight that touches your face has crossed 93 million miles, and yet it belongs here, with you, on this small blue world that balances perfectly between fire and frost. Earth is a rare serenity in the universe, a fragile balance held by gravity, sunlight, and time. It is proof that chaos can give rise to harmony, that stillness can exist even within motion. Every sunrise, every rainfall, every moment of silence beneath the stars is a continuation of that balance. You are part of it, woven into the fabric of its calm. So breathe softly, feel the warmth of the world that made you, and let yourself rest in the quiet certainty that, for this moment, everything is exactly as it should be. 6. The moon, Earth's silent companion. When night falls and the world grows still, the moon rises, calm, unhurried, and luminous. It glides through the dark like a slow breath of light, reflecting the sun's glow across oceans and forests, mountains and cities. The moon is not a source of light itself, but a mirror, a patient witness that gathers sunlight and scatters it softly back to Earth. For as long as there have been eyes to look upward, its pale face has watched over every life that sleeps beneath it. The moon is our oldest companion, our quiet partner in the long drift of time. It is easy to forget how far away it truly is. The moon hovers about 380,000 kilometers from Earth, a distance so vast that you could line up every continent between us and still not reach it. Yet in the scale of the cosmos, it is astonishingly close, close enough that its gravity pulls on our oceans, close enough that its reflected light guides nocturnal creatures through the night. It circles our planet once every 27 days, locked in a gentle rhythm that has not changed for billions of years. This rhythm is woven into the Earth's own motion, the two bodies turning in an endless dance that binds them together through gravity and silence. From the beginning, the moon has been part of us. Scientists believe it was born in violence, a fragment of Earth itself, torn away by a colossal impact, with a body the size of Mars. The debris from that collision circled the planet, glowing and molten, until gravity drew it together into a single sphere. Over time, the new moon cooled, hardened, and took its familiar form. The scars of that ancient birth are still visible today. Vast plains of solidified lava, craters that stretch for hundreds of kilometers, and mountains carved by the last breath of molten tides. When you look up at the moon, you are seeing the face of Earth's own lost piece, a remnant of our planet's earliest memory. The side we see, the near side, is always the same. The moon is tidally locked, meaning it rotates at the same rate that it orbits Earth. As it turns, one face is forever gazing toward us, while the other, the far side, remains unseen from the ground. For most of human history, that hidden half was a mystery, imagined as a realm of shadow or myth. Only when spacecraft circled the moon did we finally see it, rougher, older, more cratered, untouched by the lava plains that smoothed the side we know. It is a reminder that even in companionship, there are parts that remain private, unseen, yet deeply connected. The moon's gravity reaches across space to touch our world, pulling gently on the oceans. Twice each day, this invisible hand lifts the sea, creating tides that rise and fall, like the Earth's own slow breathing. These movements shape coastlines, nourish marine life, and have guided human rhythms for millennia. The pull of the moon does more than stir the water, it steadies the Earth itself. Without it, our planet's tilt would wobble wildly, sending climates into chaos. The moon acts as a stabilizer, holding Earth's axis in place, ensuring that our seasons remain steady and our environment habitable. It is the quiet guardian of balance, unseen yet indispensable. If you could stand on the surface of the moon and look back toward Earth, you would see a sight that defies description. The sky above you would be perfectly black, scattered with unblinking stars, and there, suspended against that darkness, would hang Earth vast, bright, and blue. Clouds would swirl across its surface, oceans would gleam with reflected sunlight, and you would see the slow rotation of continents drifting beneath their blanket of air. The Earth would not rise or set as the moon does from here. It would hang in the same spot in the sky, forever turning, glowing with all the light and motion of life. It would look alive. It would look like home. The surface of the moon is silent in the truest sense. There is no air, no wind, no water. Sounds cannot travel there. The ground is made of fine gray dust, each grain sharp and dry, untouched by erosion for billions of years. Footprints pressed into it by astronauts half a century ago remain as fresh as the day they were made, preserved in the stillness of vacuum. The rocks that litter its plains are relics of a time when the moon's interior was molten, when lava flooded ancient basins and cooled under the faint light of a distant Sunday. To touch one would be to touch time itself, a fragment of the early solar system resting in eternal quiet. The moon has many moods, though they change only in light. As it moves around Earth, sunlight paints its surface in phases, crescents, halves, and full circles that follow one another with steady grace. These phases are not just visual poetry, they are a measure of time. Before calendars, before clocks, humanity marked its days by the moon's rhythm. Entire cultures grew around its cycle. Harvests were planted by its light, and journeys were guided by its waxing and waning. Its phases became symbols of renewal, of growth and decay, of the eternal return. Even now, we feel that rhythm instinctively, as if the turning of the moon were written into our blood. During a lunar eclipse, when Earth's shadow falls upon its face, the moon takes on a deep, copper-red glow. It is a haunting sight, the reflection of sunlight refracted through our atmosphere, bending around the planet to paint the moon in shades of dusk. For a brief time, the three bodies, Sun, Earth, and Moon, align perfectly, creating a cosmic geometry of shadow and light. Watching it, one feels the vastness of the universe contract into something intimate, something almost tender. The same forces that govern galaxies are, in that moment, visible from your backyard. Throughout human history, the moon has been both a mystery and a companion. It has guided travelers, inspired songs, and reflected the stories of every civilization that looked upward. Poets have called it a mirror of the soul. Scientists have called it a laboratory of creation, and lovers have called it a witness to the heart. Its pull is more than gravitational. It draws our imagination as surely as it pulls the sea. We have walked upon its surface now, left traces of our curiosity in its dust, and yet it remains distant, untouched in essence. For all our technology and exploration, the moon keeps its secrets close. And yet, even in its silence, the moon speaks. It tells us about time, about cycles and returns, about patience. It teaches that illumination comes not from generating light, but from reflecting it. Its glow reminds us that beauty often lies in what we give back, not in what we possess. Just as the moon reflects the sun, so do we reflect the world around us, carrying its light in our eyes, in our minds, in our stories. At night, when the moon is full and the air is still, you can almost feel its presence. It hangs low and heavy, casting soft shadows across the land. The world seems quieter under its glow. Animals move more carefully, waves rise higher, and even the wind holds its breath. In that silver calm, there is a sense of connection that defies words. You are seeing the same moon that shone over the first fires of humanity, the same that watched over the first ocean, the same that will shine long after we are gone. Its light is ancient but never old, a rhythm that has never faltered. As you drift toward sleep, imagine that light spreading gently across the earth. It touches the mountains and oceans, the forests and deserts, the cities and the quiet fields. It glances off rivers, slides across windows, and rests upon closed eyes. It is the same light that has always been, a whisper of sunlight made tender by reflection. The moon will continue its orbit through the night, faithful and silent, carrying its pale glow across the turning earth. And when dawn comes, it will fade without protest, surrendering once more to the sun, content in its eternal role, the watcher, the reflector, the quiet companion that follows us through the dark, guiding us home to morning. 7 Mars, the red memory of water. Mars drifts through the dark, like a silent ember, glowing faintly red against the black expanse of space. To the naked eye, it seems small and calm, a steady point of rust-colored light tracing the slow rhythm of the planets. But beneath that tranquil glow lies a world that once may have been alive, with movement, rivers flowing through valleys, rain falling on ancient plains, and oceans reflecting a young Sunday. Mars is a planet of memory, a world that once dreamed of water but now sleeps beneath dust. It is the echo of what might have been, the still heart of a story half remembered by the universe itself. From orbit, Mars appears as a vast desert painted in shades of red and ochre, its surface streaked with dark plains, pale plateaus, and canyons that cut across continents. The red hue that defines it comes from iron oxide rust, spread across its soil and rock. It is the planet's signature, a permanent blush of oxidation that gives it its nickname, the Red Planet. Yet there is something deceptive about that color. It suggests warmth, but Mars is cold, colder than any desert on Earth. Its air is thin, its winds sharp, and its sunlight weak. The red we see is not heat, but memory, the residue of a time when Mars was young and alive. Billions of years ago, Mars was not so dry. Evidence carved into its terrain tells the story. Channels that wind like the paths of ancient rivers, delta fans that once spread where streams met standing water, minerals that could only have formed in lakes and seas. Long ago, its atmosphere was thicker, its surface warmer. Water ran freely then, shaping valleys and carving cliffs, leaving behind sediment and salt. The planet likely had clouds and rain, perhaps even an ocean covering much of its northern hemisphere. For millions of years, it may have looked almost Earth-like, its skies tinted pink by dust, but its world still blue with water. But the balance did not last. Slowly, Mars lost the warmth it needed to hold onto its air. The reason lies deep within its core. Unlike Earth, Mars is smaller, and its interior cooled more quickly. As the core solidified, the magnetic field that once shielded the planet from solar wind faded. Without that protection, the sun's charged particles began to strip away the atmosphere, atom by atom, sending it streaming into space. The pressure fell, and the remaining air thinned until liquid water could no longer survive on the surface. Rivers evaporated, lakes froze. The ocean withdrew into the ground, leaving behind salt, plains, and empty basins. In time, the planet turned to dust, its memory of water preserved only in rock. Even now, traces of that water remain. Beneath the surface, scientists believe pockets of ice and frozen brine persist, hidden in the soil and at the poles. Each winter, the polar caps expand as carbon dioxide freezes into dry ice, then retreat again with the return of spring. Below that shifting frost, layers of water ice lie thick and ancient, storing the planet's history in translucent strata. When sunlight touches them, some of the ice sublimates directly into vapor, feeding thin clouds that drift across the sky like faint ghosts of the oceans that once were. On Mars, water still moves, but in whispers, a frozen breath, a thin mist, a passing trace that fades as quickly as it appears. The surface of Mars bears the marks of a world both violent and still. Volcanoes tower across its plains, the largest in the solar system. Olympus Mons rises 3 times higher than Mount Everest, its base so wide that it could cover the entire state of Arizona. Yet this giant has been dormant for millions of years, its fire extinguished as the planet cooled. Nearby, the canyons of Valles Marineris stretch for 4,000 kilometers, a scar across the equator so vast that it would span the distance from New York to Los Angeles. These features speak of a planet that once breathed heat and movement, whose crust cracked and shifted as its inner life ebbed away. The Martian air is thin, less than 1% of Earth's atmospheric pressure. A breeze there moves faster than a gale, but carries almost no weight. And yet, over time, even this sparse wind has shaped the land. Dust storms sweep across entire hemispheres, lifting fine red grains into the sky until the planet is wrapped in haze. These storms can last for weeks, softening the harsh outlines of craters and dunes. The dust settles slowly, layer upon layer, a quiet shroud that hides the ancient scars beneath. In this way, Mars is constantly erasing and remembering itself, its surface a palimpsest of storms and silence. The planet's 2 small moons, Phobos and Deimos, orbit close and fast, captured fragments of rock that circle like anxious attendants. Phobos, the larger, rises in the west and sets in the east, racing across the sky in just 4 hours. Each time it passes overhead, it drags faint tides through the thin air and dust. It is slowly spiraling inward, inching closer to Mars with each orbit. One day, it will fall and break apart, its fragments forming a brief ring before they drift down as meteors. Deimos, smaller and farther away, moves more gently, its orbit stable and quiet. Together they embody the planet's nature, restless and fragile, circling always, waiting for collapse. Mars has fascinated humanity for as long as we've looked at the night sky. To the ancients, its reddish glow resembled fire and blood, and they named it after their gods of war. Yet when our machines arrived there, they found not battle, but stillness. No sound, no rivers, no cities, only a landscape of wind and dust, frozen in mid-motion. The warlike planet turned out to be peaceful, patient, and lonely. But it is precisely that silence that draws us to it. In Mars, we see not conquest, but curiosity. We see the reflection of our own fragility, the thin line between life and absence. Rovers, like spirit, opportunity, curiosity, and perseverance, have wandered across its plains, leaving tracks that may last for centuries. They have touched the stones that once lay beneath ancient lakes, tasted the dust for traces of carbon and water, listened to the faint sigh of wind across empty ground. Each mission brings us closer to understanding not only Mars, but ourselves. When a rover sends back a picture of its horizon, the view is strangely familiar. Hills under pale sky, shadows stretching across sand. It feels almost like home, as though the planet is waiting for us to return, or perhaps reminding us of where we came from. Mars holds a mirror to Earth's possible futures. It shows us what happens when a planet loses its warmth, when air fades and water retreats. It is not a warning spoken in fear, but a quiet truth written in stone. Balance is fragile, and even worlds can change beyond recognition. Yet Mars also whispers of resilience. For billions of years it has endured cold, yes, but enduring. Its mountains still standing, its polar caps still shining. Life, if it ever began there, may not be gone at all, only hidden, waiting beneath ice or stone for its time to return. When you look up and see Mars glowing in the sky, know that the light you see has traveled millions of miles through emptiness, reflected from a world that once knew rain. It is the color of memory, not of blood or battle, but of rust and sunlight, of things that once moved and now rest. In that gentle red light lies a kind of peace, a reminder that even in loss, beauty remains. The rivers may be gone, but their paths are written across the planet's skin like the lines of an ancient poem. The water may be frozen, but it still holds the imprint of life's possibility. As you drift toward sleep, imagine standing on Mars beneath its dusky sky. The horizon glows faintly, pink, the sun a small, cold disk sinking into distance. The air is silent, the ground still. Overhead, Earth is a bright blue star, hanging motionless in the thin light. It is strange to think that our home, so full of sound and color, would appear from there as nothing more than a point of light. Yet that light carries everything: oceans, forests, voices, dreams. Mars watches it rise and set, as it has for eons, a quiet neighbor in the endless night. And though it seems desolate, the planet is not dead. It waits, as it always has, keeping the memory of water safe beneath its dust, patient as stone, silent as time, forever orbiting in the soft red glow of its own remembering. 8. The asteroid belt, the world that never was. Between Mars and Jupiter lies a vast expanse of quiet space, a region neither fully empty nor truly full. A scattered field of stone and ice drifting endlessly in the dark. This is the asteroid belt, the boundary between the inner, rocky planets and the outer giants. From a distance, it might sound like a chaotic realm, a place where rocks collide in a storm of motion. But in truth, it is mostly stillness. The asteroids are separated by hundreds of thousands of kilometers of emptiness. They move in their orbits like patient dancers, following invisible lines drawn by gravity. Here, silence reigns. And yet, within this calm lies one of the solar system's great what-ifs, a world that almost was, but never came to be. The asteroid belt is a graveyard of beginnings. These countless fragments are remnants from the dawn of the solar system, leftover material that never found its way into a planet. When the young sun was surrounded by its disk of gas and dust, every region of that disk tried to form a world. Near the sun, Mercury and Venus emerged from metals and rock. Farther out, beyond the frost line, Jupiter grew massive enough to gather gases into its wide embrace. But in the narrow space between Mars and Jupiter, that process stalled. The reason was gravity. Jupiter's immense presence disrupted everything nearby. Its pull was too strong, its resonance too insistent. Every time the fragments tried to coalesce, its gravity tore them apart. The growing planet's influence stirred the region into constant motion, preventing the dust and rock from settling into a single body. Over time, what might have become a planet remained forever, broken a sea of fragments circling the sun in quiet disarray. In that sense, the asteroid belt is not merely a collection of stones. It is the outline of a lost possibility, a world that almost existed. If you could drift among these fragments, you would find great variety in their forms. Some are only grains of dust. Others are mountains adrift in the dark. A few are large enough to be called dwarf planets. Ceres, the largest of them all, is nearly 1,000 kilometers wide round from its own gravity, with hints of ice beneath its crust and bright salt deposits that gleam like scattered stars upon its surface. Vesta, slightly smaller, bears the marks of massive impacts that have gouged valleys and craters across its body. Between these, giants are countless smaller stones, tumbling slowly through space, each one a tiny record of the solar system's youth. The asteroids are irregular, misshapen, and ancient. Their surfaces are gray and cratered, untouched by atmosphere or erosion. Some are dark with carbon, the building blocks of life embedded in their dust. Others are bright and metallic, shards of iron and nickel that once might have formed the cores of unfinished worlds. When sunlight touches them, they shine faintly, their reflections flickering like distant embers in a sea of black. Though they are scattered across millions of kilometers, they share one orbit, circling the sun as though bound by memory rather than motion. Every so often, these fragments cross paths. Their collisions are slow but powerful, chipping away at their surfaces or sending shards drifting into new trajectories. Some of these fragments fall inward, drawn toward the inner planets. Over eons, a few find their way to Earth, burning as meteors through the atmosphere or landing as stones that scientists will one day hold in their hands. Each meteorite is a messenger from this quiet region, carrying within it the chemical history of creation, minerals unchanged since the time when the planets were young. To hold one is to touch the unshaped past, the raw material from which worlds arise. The asteroid belt is not a single place, but a continuum of orbits, a bridge between realms. Beyond Mars, the sun's light begins to weaken, and the heat fades into the chill of space. The asteroids mark that transition, the boundary between the warm, rocky zone and the icy territories of the giants. They are the middle ground of the solar system, neither too near nor too far, neither soft nor frozen. In their quiet persistence, they embody balance, not the dynamic balance of living planets, but the calm balance of time itself, where change happens slowly, invisibly, patiently. Many asteroids are accompanied by smaller moons, pebbles bound by gravity to their larger companions. Some travel in families, remnants of ancient collisions that broke apart a single parent body. Others share orbits with planets, like Jupiter's Trojan asteroids, which move ahead of and behind the giant in stable pockets of space. The solar system is full of such quiet arrangements, places where gravity and time cooperate to create order out of drift. The asteroid belt is perhaps the most subtle of these, a vast sculpture of motion that reveals the unseen symmetry of the sun's pull. It is easy to imagine the belt as a dangerous place, a gauntlet of tumbling rocks as seen in stories of fiction. But in reality, the emptiness is profound. A spacecraft traveling through it would almost certainly never collide with anything. The vastness between objects is so great that one could pass through the entire region without ever seeing an asteroid up close. The danger lies not in their abundance, but in their isolation. Each fragment is alone, following its orbit through silence, never meeting another except by chance. It is a place of solitude on a cosmic scale, a vast expanse of what might have been. Yet there is beauty in that solitude. The belt glows faintly with the light of distant dust, a soft haze that astronomers call the zodiacal light. It appears as a faint cone of radiance in the night sky, visible just before dawn or after sunset, sunlight scattered by the countless grains drifting between worlds. It is a subtle reminder that even the smallest fragments contribute to the larger glow. The belt, though composed of broken pieces, creates a collective shimmer that stretches across the inner solar system, a cosmic sigh made visible. Somewhere within this region, the remnants of countless collisions still wander. Over time, gravitational nudges send a few of them drifting toward the inner planets. Many burn up harmlessly in Earth's atmosphere, lighting the night with meteors that streak briefly and vanish. Others land, bearing carbon compounds, amino acids, and complex molecules, the very ingredients that may have seeded life on Earth long ago. In that sense, the belt is not only a relic of failed creation but also a giver of beginnings. What it could not become itself, it may have shared with us. The world that never was may have helped give rise to the world that is. The asteroid belt's silence is deceptive, for it is not empty of story. Every stone carries within it the memory of heat and collision, of slow cooling and endless orbit. Each one is a page from the solar system's oldest book, written before Earth had oceans or air. If you could float among them, listening somehow to the vibrations of their movement, you might hear a deep, slow harmony, the hum of rocks circling in time with the sun, the soft music of gravitational balance. It would not be a song of motion, but of patience, of things content to remain as they are. And so the belt continues, unhurried, unchanged. The sun rises and sets over its scattered stones in silence, light crossing the void without resistance. Jupiter's vast pull still shapes its edges, keeping it from becoming something more, but also preserving it as it has always been. It is the still point between two worlds, the fiery inner system and the cold expanse beyond. It is a reminder that not every beginning finds its completion, that sometimes what remains unfinished still holds its own kind of grace. As you drift toward rest, imagine that quiet region between planets. Picture the stones turning slowly in sunlight, their shadows stretching across emptiness. There are no storms there, no sound, no movement beyond the gentle pull of orbits, only the persistence of time, the patient gravity that holds everything in place. Asteroid belt is not failure. It is pause. It is the breath the solar system takes between creation and continuation. And in its vast, enduring stillness, it offers a kind of peace that only the universe can know, the peace of what could have been, softly becoming what simply is. 9. Jupiter, the gentle giant of storms. Beyond the asteroid belt, the light of the sun grows dimmer, yet still it glints off something vast. A planet so enormous that it could swallow every other world and still have room to spare. Jupiter, the first of the giants, rules this outer kingdom of the solar system. It is not a world of rock and soil, but of cloud and storm, an endless atmosphere swirling in shades of amber, ivory, and rose. From afar, it appears both serene and powerful, a marble of gas suspended in the dark. Up close, it is motion incarnate, a planet made entirely of weather, where lightning flashes in perpetual storms and winds circle the globe faster than sound. Jupiter is gravity, given form, a world so massive that it shapes the orbits of everything around it, holding comets, moons, and even sunlight in its invisible grasp. If Earth is the cradle of life, then Jupiter is its guardian. The planet's immense gravity acts as a shield, pulling countless asteroids and comets toward itself, sparing the inner worlds from destruction. Many of the impacts that might have scarred Earth have instead been drawn to Jupiter's wide embrace, vanishing into its deep atmosphere in silent bursts of light. In this way, the planet serves as a protector, a giant sentinel watching over the smaller worlds that circle closer to the Sunday. Its presence stabilizes the solar system, anchoring it like a great weight that keeps the rest of the planets in place. Yet Jupiter is not merely a massive body of gas. It is a masterpiece of motion, beauty, and contrast, a world that breathes storms and sings with lightning. The planet's outer layers are made mostly of hydrogen and helium, the same elements that fuel the Sunday, but where the sun burns, Jupiter glows softly, its heat not born from fusion but from compression. The planet's gravity squeezes it so tightly that it radiates more energy than it receives, glowing with a faint inner warmth, a memory of its own formation. Deep within, pressure rises to unimaginable levels. Scientists believe that beneath the colorful clouds lies a vast ocean of metallic hydrogen, a strange, shimmering liquid that conducts electricity and reflects light like polished steel. Still deeper, perhaps, lies a dense core of rock and metal, the seed from which Jupiter grew. From its swirling top, Jupiter appears in bands of color that stretch endlessly from pole to pole. These stripes are not static but alive, driven by winds that race in opposite directions at different latitudes. The light zones are regions of rising gas, cool and pale, while the darker belts are sinking currents, warmer and dense. Between them form waves and eddies, currents that twist and merge like living rivers of air. The clouds themselves are made of ammonia and water crystals, tinted by unknown chemicals that give them their golden and ruddy hues. Watching them move is like witnessing the breathing of a god, slow, powerful, and eternal. And then there is the Great Red Spot, Jupiter's most famous feature, a storm larger than Earth itself that has raged for centuries. It spins counterclockwise in the southern hemisphere, an endless cyclone of gas and pressure, its winds reaching speeds of hundreds of kilometers per hour. Within it, colors shift from coral to crimson to faded peach, depending on the height and density of the clouds. Though the storm has slowly shrunk over time, it remains immense, a reminder of the planet's restlessness. When spacecraft have passed close enough to see it in detail, the storm's edges have been revealed as curling waves of turbulence, intricate and fragile. Despite their power, it is both terrifying and graceful, a storm so vast it could swallow our world whole, yet so delicate that it glows softly under sunlight, like a rose floating on an endless ocean of wind. To stand above Jupiter, if such a thing were possible, would be to see motion made infinite. There is no solid ground, no horizon, no stillness. The planet has no surface to stand upon, only layers upon layers of gas, each one different in temperature and color, stretching thousands of kilometers deep. If one were to descend into its atmosphere, the pressure would increase swiftly, crushing anything that dared fall too far. The light would dim, the winds would rise, and then, deeper still, gases would turn to liquid under pressure, the very definition of matter blurring. In time, even light itself would struggle to escape. swallowed by the dense glow of heat and gravity. Jupiter is not a place one could visit. It is a phenomenon, a living storm that spans the size of a miniature Sunday. Yet for all its violence, there is peace in its rhythm. Jupiter's storms are not chaos, but choreography. Each movement follows invisible laws of physics, every band and swirl maintaining a balance between temperature, rotation, and gravity. Even its storms have stability, patterns that persist for decades or centuries before fading into new forms. To watch Jupiter is to see the elegance of order within motion, the same balance that governs the tides of Earth, the orbits of moons, and the cycles of stars. It is as if the planet itself is meditating, its clouds breathing in slow, colossal rhythm, never truly beginning or ending. Surrounding Jupiter are dozens of moons, each a world of its own. 4 of them, Io, Europa, Ganymede, and Callisto, are large enough to be planets in their own right. They orbit in a perfect gravitational harmony, their movements locked in a precise mathematical dance. Io, the innermost, is a world of fire, covered in volcanoes that erupt constantly under Jupiter's tidal pull. Europa is a world of ice, its smooth surface concealing a vast ocean beneath. Ganymede, the largest moon in the solar system, has its own magnetic field and hidden seas. Callisto, cratered and ancient, circles farther out, silent and scarred by time. Each of these moons tells a story written in Jupiter's shadow, stories of creation, of heat, of gravity's endless art. When sunlight touches Jupiter, it reflects softly, scattering through its hazy clouds. The planet shines in the sky as one of the brightest objects visible from Earth, second only to Venus. To the human eye, it seems calm, a pearl in the night. But behind that serenity lies movement beyond imagination. Lightning flashes in its depths, bolts so vast they would dwarf entire continents. Radio waves hum from its poles, created by the interaction of its magnetic field with charged particles streaming from the sunday. That magnetic field is immense, stretching millions of kilometers into space, forming a shield. So strong it captures radiation and particles like a net of invisible fire. Jupiter glows not only with sunlight, but with its own unseen energy, a beacon in both light and radio waves. When we sent probes to study it, Pioneer, Voyager, Galileo, Juno, they revealed a planet more complex and more beautiful than we ever imagined. The images they returned showed textures and patterns so fluid that they seemed painted, each swirl a masterpiece of motion. Yet those colors are not decoration, they are chemistry, the visible trace of reactions happening in real time within Jupiter's vast body. Each shade of cream, rust, and gold is a note in the planet's silent music, a harmony too slow and deep for us to hear, but one that the universe surely knows. Jupiter's enormity humbles everything around it. It contains more mass than all the other planets combined, yet it orbits with gentle grace, maintaining perfect distance from the sunday. It does not compete, it simply exists, vast, stable, and patient. It reminds us that size does not equal chaos, that power can coexist with peace. The same gravity that could tear worlds apart also holds them steady, preserving the fragile harmony of the solar system. In its presence, everything else finds its place. And so, as night falls on our small blue world, Jupiter rises steady, glowing, immense. Its storms continue to turn, its moons glide in silence, and its gravity hums across billions of miles. It is the great heart of the outer solar system, the gentle giant whose storms have raged since before life began. When you see its pale light in the night sky, know that you are looking at motion itself, slowed into grace. Jupiter turns, and with it, so do we, all of us orbiting together, bound by the same invisible calm that keeps the stars and storms alike in their endless, beautiful balance. 10. Europa, the ocean beneath ice. Far from the warmth of the sun, where Jupiter reigns with its endless storms, there drifts a small, bright world, smooth, pale, and mysterious. It is Europa, one of Jupiter's many moons, but unlike the rest, it holds a secret so profound that even silence seems to listen. Europa looks quiet from a distance, its surface gleaming white beneath the faint sunlight. But beneath that calm exterior lies an ocean, vast, hidden, and alive with possibility. It is a world of water encased in ice, a planet-sized sea kept warm by the tides of gravity. In its depths may lie the same spark that once awoke on Earth, still waiting, still dreaming in the dark. Europa's surface is like no other in the solar system. From afar, it appears smooth and luminous, reflecting sunlight like polished marble. Up close, however, it is a landscape of fractured ice, a tapestry of lines, ridges, and bands that stretch across the moon like scars. These lines are not random. They are the marks of movement, the crust shifting and cracking as the tides beneath it rise and fall. The ice plates drift slowly over the hidden sea, colliding and separating like continents on a frozen ocean. Through the cracks, darker material seeps upward, staining the white surface with streaks of rust and shadow. Each line is a record of motion, a signature of the living rhythm that lies beneath the stillness. The light that touches Europa is faint. The sun, seen from its orbit, is only a bright star, and yet that distant energy is enough to make the ice glimmer softly. The temperature here is unimaginably cold, more than 150 degrees below freezing. No liquid water could survive on the surface. It would turn instantly to ice or vapor. But Jupiter's immense gravity does something extraordinary. As Europa orbits, it is pulled and stretched by the planet's force, its interior flexing slightly with each revolution. This constant kneading generates heat deep within, enough to keep the subsurface ocean from freezing solid. Thus, in the darkness beneath the ice, water remains liquid, a hidden sea warmed not by sunlight, but by the slow, steady pulse of gravity. Scientists believe this ocean may be twice as large as all of Earth's combined. It lies beneath an icy crust, perhaps 15 to 20 kilometers thick, stretching downward for more than 100 kilometers into blackness. No human eyes have ever seen it, but its presence reveals itself in subtle ways. The magnetic field, disturbed by saltwater currents, the faint geysers of vapor that burst from cracks near the poles, the shifting of surface plates that suggest a restless world below. Europa may seem frozen and still, but inside it, something moves, a vast, liquid heart beating slowly beneath layers of ice. It is difficult not to wonder what might live there. On Earth, life thrives wherever there is water, from the surface of the sea to the darkest abyss, from the roots of forests to the vents at the bottom of the ocean where sunlight never reaches. Even in places where heat and light seem absent, life finds a way. Around hydrothermal vents in Earth's oceans, bacteria and strange creatures feed on chemicals rising from the crust, building entire ecosystems independent of the sunday. If such environments exist on Europa, if vents at the ocean floor release minerals and heat into its waters, then perhaps, in that endless night, life stirs. It might be small and unseen, perhaps only microbes drifting through the dark, but it would mean that life is not confined to Earth. It would mean that the universe itself has a natural tendency toward awakening. The idea of such life moves something deep within us. For centuries, humanity has looked outward, wondering if we are alone. Europa offers an answer, whispered beneath ice. Even if no creatures swim there, the existence of its ocean reshapes what we know about worlds. It shows that warmth and life do not belong only to planets bathed in sunlight. They can exist in shadow, sustained by gravity and motion, by forces subtle and enduring. Europa is a world that reminds us that even in cold and darkness, there can be energy. And where there is energy, there may be life. The surface of Europa is young, geologically speaking. While the moon's face is pocked with craters billions of years old, Europa's is nearly smooth, constantly renewed by shifting ice. Impact marks fade as cracks heal and new ridges rise. The surface is never still for long. It flexes and shifts, recording the strain of tides in its frozen patterns. Some regions are broken into jumbled blocks, as though great plates of ice had cracked apart and refrozen in new configurations. These chaotic terrains suggest that the crust is thin in places, that the ocean occasionally forces its way upward, melting and refreezing as it interacts with the cold void above. In some spots, faint plumes have been detected, jets of vapor erupting hundreds of kilometers into space, then falling back as snow. These plumes may connect directly to the ocean below, carrying its secrets upward for a fleeting moment before vanishing. When spacecraft like Galileo and Juno pass through Jupiter's system, they sense traces of these plumes in the magnetic field, subtle hints of salt and water carried on in visible currents. If future missions can fly through them again, they may find not just water, but complex molecules, perhaps even biological signatures, chemical whispers of something alive beneath the ice. Europa's beauty lies not only in what we know, but in what we do not. It is both familiar and alien, Earth-like in its composition, yet utterly unlike anything we have experienced. Its silence is complete. There are no winds, no waves, no sound, but the faint creak of ice shifting under tension. The sunlight that falls upon it is weak, but it glows brilliantly all the same, its surface reflecting the light like a mirror for the distant Sunday. In that reflection, one can almost imagine seeing ourselves, a reminder that even in faraway worlds, there is connection, resonance, and memory. To imagine standing on Europa is to imagine standing on the edge of the unknown. The ground beneath your feet would groan faintly as tides flex the crust. The horizon would stretch smooth and white, unbroken, except for the long shadows of ridges etched by strain. Overhead, Jupiter would dominate the sky, an immense banded world filling the heavens, its storms visible even from here. The light from the sun would be dim, but Jupiter's reflection would bathe the landscape in a ghostly glow. The planet's gravity would tug gently at the ground, moving it by inches each day, a slow reminder of the forces that keep this small world alive. Europa is a paradox, a frozen moon warmed from within, a place where silence hides motion and where death-like stillness may cradle life. It is not a world of fire or sunlight, but of subtle persistence. Beneath its icy shell lies an ocean that has never seen the stars, an ocean that may have existed for billions of years, untouched and complete. To think that life might have begun there, in total darkness, nourished by minerals and warmth, is to understand how powerful and patient the universe can be. As you close your eyes and drift into rest, imagine Europa turning slowly in Jupiter's light. The ice gleams softly, the cracks shimmer faintly blue, and beneath that frozen crust, an ocean breathes. It moves in silence, its waves shaped by gravity and time, its depths endless and unknowable. The same cosmic forces that shaped our world keep this one alive, distant and patient, carrying its hidden sea through the cold night of space. Somewhere within that quiet ocean, beneath kilometers of ice, the story of life may be unfolding, once more, slowly, gently, in the dark, under the endless reflection of stars. 11. Saturn, the planet of rings and harmony. There are few sights in the cosmos as serene as Saturn, floating beyond Jupiter in the quiet reaches of space. It turns slowly beneath a pale golden glow, wrapped in rings that shimmer like frozen music. To gaze upon it is to feel a kind of peace, the same calm that one feels when watching sunlight ripple across water. Saturn moves in silence, enormous yet graceful, its rings curving outward like the notes of a song too vast for the human ear. It is a planet that embodies symmetry, order, and elegance, a world where gravity, ice, and light perform a perpetual dance of balance. From a distance, Saturn appears almost delicate. Its hues are gentle, its clouds faintly tinted in bands of cream and honey. But this quiet beauty hides a vastness beyond imagination. Saturn is immense, 9 times wider than Earth and 95 times more massive. Yet it is also the least dense of all planets, so light that if there were an ocean large enough, it would float. Its body is composed mostly of hydrogen and helium, the same ingredients that make up the stars. And beneath its soft atmosphere lies a mystery that still resists full understanding. It is a world that is both ethereal and immense, powerful and tender all at once. The most striking feature of Saturn, of course, is its rings. They encircle the planet like a halo, stretching hundreds of thousands of kilometers into space. Yet they are astonishingly thin, only a few tens of meters thick in most places. They are made of countless particles of ice and rock, each one reflecting sunlight like a tiny mirror. Some are as small as grains of sand, others are as large as mountains. Together, they form intricate bands and divisions, separated by gravitational harmonies that give the rings their structure. When viewed from afar, they seem solid and continuous, but up close, they are a vast, floating mosaic, an endless river of ice circling the planet in silence. No one knows exactly how the rings were born. They may be remnants of a moon torn apart by Saturn's gravity, or the leftover material from the planet's formation. Perhaps they are both a blend of ancient creation and quiet destruction. What we do know is that the rings are dynamic, changing slowly over time. They are sculpted by the gravity of Saturn's many moons, whose orbits create ripples, gaps, and waves across the icy bands. Some moons, called shepherd moons, move along the edges of the rings, using their pull to keep the particles in line, as though tending to a cosmic flock. In this way, Saturn's rings are alive, not static, but breathing, shifting with the rhythm of motion and time. The play of light upon the rings is a sight beyond words. As Saturn turns, sunlight catches the ice from different angles, creating waves of brightness that move like music through space. From certain perspectives, the rings vanish entirely, appearing as a thin line when seen edge-on. Then, as the planet tilts again, they widen, glowing with soft fire. They are both there and not there, both presence and illusion, like the reflection of moonlight on still water. The rings are Saturn's heartbeat made visible, the silent pulse of its gravity given shape in light. Beneath that elegant crown lies the planet itself, a world of gas and wind. Like Jupiter, Saturn has no solid surface. Its outer layers are a vast atmosphere of hydrogen and helium, streaked with bands of color that flow around the planet at tremendous speeds. Winds here can reach over 1,800 kilometers per hour, faster than any storm on Earth. Yet, because of its muted palette, these tempests appear gentle, almost tranquil from afar. The pale yellows and golds blend like brushstrokes in a painting, giving the illusion of calm even as the planet's upper atmosphere churns with energy. Saturn's storms are vast, but soft-spoken, their edges blurring rather than breaking. At the North Pole of Saturn lies one of its most mysterious features, a storm shaped like a perfect hexagon, spanning nearly 30,000 kilometers across. This six-sided jet stream spins endlessly, its pattern remaining stable for decades. It is a geometric marvel in a world of turbulence, a perfect shape carved from wind and pressure. No one fully understands why it persists, only that it endures, a symbol of order within chaos, a reminder that even the most volatile systems can produce symmetry and beauty. Saturn's moons form a kingdom of their own, each one distinct and strange. There are more than 80 that we know of, from small, irregular stones to worlds larger than Mercury. Among them are some of the most intriguing places in the solar system. Enceladus, tiny yet brilliant, reflects nearly all the sunlight that touches it, making it one of the brightest objects in space. Beneath its icy crust, like Europa, lies an ocean of liquid water. Jets of vapor and ice erupt from cracks near its south pole, spraying into space like silver fountains. These geysers feed Saturn's faint outer ring, connecting moon and planet in a loop of motion, renewal. Titan, Saturn's largest moon, is another wonder wrapped in a dense orange haze, with rivers, lakes, and seas not of water, but of liquid methane and ethane. It rains there, it flows, it evaporates, creating a complete weather cycle in alien form. In Titan, we see a second Earth of sorts, familiar in process, yet entirely other in substance. All of Saturn's moons play roles in shaping the planet's symphony. Some pull on the rings, creating resonant patterns. Others share orbits in delicate gravitational balances. The entire system moves as one planet, rings, and moons bound together in an intricate harmony. It is as though Saturn itself were conducting a celestial orchestra, each moon and ring particle responding to its gravitational rhythm, producing a music too deep and slow for us to hear. When spacecraft visited Saturn, first the Pioneers, then the Voyagers, and finally Cassini, they revealed the planet in all its luminous detail. The Cassini mission, in particular, spent more than a decade orbiting the giant, sending back images of sublime stillness, light glinting off the rings, shadows stretching across the clouds, moons drifting like pearls through the darkness. It showed us that Saturn is not merely beautiful, it is alive with subtle motion. The spacecraft's final dive into Saturn's atmosphere in 2017 was both an ending and a continuation, a return of a small human creation to the world it had studied for so long. In that act, there was poetry, a reminder that even in exploration there is reverence, and in endings there is grace. Saturn, more than any other planet, evokes calm. Perhaps it is the symmetry of its rings, or the softness of its light. Perhaps it is the knowledge that its beauty lies in fragility. The rings will not last forever. Over millions of years, the icy particles will fall slowly toward the planet, burning as they descend, until one day the rings will fade. But that, too, is part of the cycle. Nothing in the universe remains unchanged, and Saturn's eventual transformation will only mirror the slow evolution of all worlds. Its fleeting perfection makes it all the more profound. If you look at Saturn through a telescope on a clear night, you can feel the quiet distance between yourself and it. The light reaching your eyes has traveled for more than an hour through space, bouncing off ice that circles a world 1 billion kilometers away. Yet it feels close, familiar, gentle. It is the light of harmony, the light of gravity shaped into form. As you drift towards sleep, imagine Saturn turning slowly in the dark. Its rings shimmer softly, catching the faint sunlight and scattering it like dust across space. Its moons move in their orbits, each one glowing faintly in reflection. The planet itself hums with balance, its storms silent, its symmetry complete. In that endless rotation, you can almost hear the music of the cosmos, calm, cyclical, eternal. Saturn does not rush. It does not change quickly. It simply exists in perfect grace, a golden world wrapped in frozen light, turning forever in the quiet rhythm of the stars. 12 Titan, the moon, with rivers of methane. Far beyond the blue of Earth and the golden clouds of Saturn lies a world of orange haze and quiet mystery. Titan, Saturn's largest moon, turns slowly through the dark like a smoldering ember, its atmosphere thick and soft, its surface hidden beneath veils of mist. It is a world both familiar and alien, where rivers flow and rain falls, where lakes glisten under pale light, and yet nothing there is made of water. Titan is a world sculpted by methane, a mirror of Earth rendered in a different chemistry, a place where the familiar rules of nature have been rewritten in colder tones. It is both distant and intimate, a frozen echo of home. When the Voyager spacecraft first passed Titan in the early 1980 seconds, it saw little more than a sphere wrapped in haze. The moon's dense atmosphere concealed everything below, turning it into a perfect enigma. Later, the Cassini spacecraft and its companion probe, Huygens, would lift that veil. As Cassini orbited Saturn, it peered through the haze with radar and infrared light, while Huygens descended gently to Titan's surface. What they revealed astonished us. Valleys carved by flowing liquid, dunes shaped by wind, and great seas stretching toward the horizon. But instead of water, the rivers and lakes of Titan are made of liquid methane and ethane hydrocarbons that on Earth exist only as gas. In Titan's deep cold, where the temperature stays near -180 degrees Celsius, they are liquid, flowing and evaporating just as water does in our own skies and seas. Standing on Titan, the sunlight would seem dim, filtered through the orange mist that wraps the world in twilight. The air would feel heavy, thicker than Earth's, yet it would move gently, stirred by slow winds that have shaped dunes of dark, organic sand. The sky would glow softly, the sun only a bright point above, its light scattered and turned to amber by the methane haze. The horizon would appear close and blurred, the surface beneath your feet solid yet strangely soft, a mixture of ice and hydrocarbon dust. In the distance, lakes would glimmer like pools of glass, smooth and still, reflecting the faint gleam of Saturn's rings hanging low in the sky. Titan's landscape is a masterpiece of alien geology. Its rivers wind through valleys, branching into deltas where they meet methane seas. Its dunes stretch for hundreds of kilometers, formed from tiny grains of complex organic material created high in the atmosphere. These particles fall slowly like snow, accumulating over millennia into vast fields of black sand. Near the poles, great seas of liquid methane, Kraken Mare, Ligeia Mare, and Punga Mare cover thousands of square kilometers. Their surface is calm beneath an eternal twilight. Beneath the crust, scientists believe, lies another ocean, not of methane, but of liquid water mixed with ammonia. Like Europa and Enceladus, Titan may hide a warm ocean below its frozen exterior, an inner sea that could cradle the chemistry of life. The air of Titan is mostly nitrogen, the same gas that dominates Earth's atmosphere. This makes Titan the only other world in the solar system with a thick nitrogen envelope. Mixed with methane, it forms clouds and haze that give the moon its orange glow. When sunlight strikes these gases, it triggers chemical reactions that build long chains of carbon-based molecules, the building blocks of organic chemistry. These compounds drift downward, coating the surface in a fine mist of complex carbon, forming the raw ingredients from which life might someday emerge. Titan's atmosphere, dense and layered, is not just a veil, it is a laboratory, constantly creating new molecules, a slow and silent engine of chemistry. The Huygens probe's descent through this atmosphere in January 2005 was like a dream falling into motion. As it drifted downward under parachute, its cameras glimpsed the shapes of river channels, ridges, and plains. The probe measured the pressure and temperature of the air, tasting methane as it fell. When it finally touched the surface, it landed softly on damp sand, the first and only human-made object to rest upon Titan. For 72 minutes it transmitted data, whispering its final messages through the haze before falling silent. Those last images of rounded stones shaped by flow, of a dim and misty horizon, remain among the most haunting ever captured. They showed a world alive not with biology, but with geology, weather, and movement. Titan, though frozen, was dynamic, a living system of rivers, rain, and air. On Titan, rain falls slowly, each droplet heavy and deliberate. It drifts through the atmosphere for hours before touching the ground. Sometimes it fills the rivers, other times it evaporates before it lands. Storms roll gently across the landscape, spreading waves through the lakes and softening the dunes. There is no thunder, no flash of lightning, only the soundless rhythm of liquid methane falling on frozen plains. These cycles of evaporation, condensation, and rain form a methane version of the hydrological cycle we know on Earth. The planet breathes with liquid and vapor, maintaining a quiet balance between sky and surface. It is both strange and achingly familiar, a reflection of our own world seen through another lens. The gravity on Titan is low, only about 1/7 that of Earth. A person could walk easily, feeling weightless yet grounded, each step slow and light. The thick air would cushion every motion. Even the simplest acts, lifting a hand, turning a head, would feel graceful, as if one were moving underwater. The sound would travel softly, muffled by the dense atmosphere. There would be no sharp noises, only gentle echoes, like whispers through fog. It would feel like standing inside a dream, a place halfway between the physical and the imagined. Titan's connection to Saturn adds to its quiet poetry. From the surface, the planet would appear enormous in the sky, a pale, golden sphere surrounded by its luminous rings. The sight would fill half the horizon, glowing faintly through the haze, a constant presence watching over its moon. The gravitational pull between Saturn and Titan shapes both their orbits, creating tides not of water but of solid ice, lifting and lowering the crust by meters. Even in this frozen world, motion endures the slow breathing of stone and ice under the weight of gravity. Scientists often speak of Titan as a world frozen in time, a snapshot of what Earth might have been before life began. Its chemistry mirrors that of our own early atmosphere, nitrogen, methane, and organic compounds forming under sunlight. Yet Titan exists in deep cold, preserving these reactions without the interference of biology. It is like a cosmic museum of possibility, showing what the ingredients of life might become in a different environment. And perhaps, beneath the icy crust, where water and heat may mix, something has already begun, a different form of life. One that breathes methane as we breathe oxygen. One that exists not in oceans of water, but in seas of hydrocarbons. Titan is both a mirror and a mystery. It shows us that nature repeats its patterns, sculpting rivers, clouds, and weather wherever conditions allow. The universe, it seems, favors rhythm, whether in carbon or ice, methane or water. The same shapes emerge: valleys, deltas, lakes, all born from flow and erosion, from the eternal balance of gravity and motion. To look at Titan is to realize that beauty is not unique to Earth. It is a universal language written in the physics of form. As you close your eyes, imagine drifting above Titan's surface. The orange mist swirls below, revealing flashes of lakes and dunes. Saturn's rings glimmer through the haze, their reflection faint but real. Far below, rivers of liquid methane curve towards silent seas, their surfaces smooth as glass. The world is still, yet alive, with slow movement, the wind brushing the dunes, the rain falling softly, the planet breathing in cycles measured not in days, but in ages. Titan drifts through the dark, circling its golden parent in endless calm. Its rain continues to fall, its lakes continue to shine, And in that frozen silence, somewhere beneath its clouds, the chemistry of life hums quietly, waiting, patient, timeless, and eternal. 13. Uranus, the planet that rolls through space. In the outer reaches of the solar system, where sunlight fades to a pale whisper and the stars begin to reclaim their dominance, there drifts a world unlike any other. Uranus turns there, slowly and silently, wrapped in shades of icy blue and green. It is a planet both strange and serene, a world that defies the ordinary motions of the cosmos. Unlike every other major planet, Uranus spins on its side, tilted almost completely over, as though some ancient force knocked it from its proper posture. It rolls through space like a sleeping giant turning in its dreams, its poles facing the sun in long, slow seasons that last for decades. Everything about it feels deliberate, unhurried, a planet that seems to have chosen its own rhythm, content to move differently than the rest. From afar, Uranus looks simple, a smooth sphere of pale blue, featureless and still. Yet beneath that calm exterior lies a story of quiet violence. Long ago, perhaps in the earliest days of the solar system, Uranus may have collided with a massive body, an impact so great that it tipped the planet on its side. That single event changed its destiny forever. Its axis now lies nearly horizontal, its poles pointing toward the plane of its orbit. While other planets spin like tops, Uranus rolls like a marble across a table, its day-night cycle twisted into something strange and beautiful. For nearly half its year, 42 Earth years, one pole faces the sun continuously, while the other lies in darkness. Then the cycle reverses, light and shadow trading places in a rhythm, too vast for human perception. The planet's gentle color belies its cold. Uranus is one of the coldest places in the solar system, with temperatures plunging to -224 degrees Celsius. Its faint blue hue comes from methane in its atmosphere, which absorbs red light and scatters the shorter blue wavelengths back into space. Beneath that delicate color lies a deep, dense atmosphere of hydrogen, helium, and more methane, blending downward into water, ammonia, and icy compounds compressed by pressure into strange, exotic forms. There may be no solid surface at all, just layers upon layers of gas and ice, merging imperceptibly toward a small rocky core. It is a world without edges, a place where air becomes ocean, and ocean becomes sky. Despite its calm appearance, Uranus is a world of hidden motion. Winds circle the planet at speeds exceeding 800 kilometers per hour, driving faint bands and storms that are barely visible through the haze. These tempests do not rage like those of Jupiter or Neptune. Instead, they move softly beneath the cloud tops, leaving only subtle traces in the planet's pale face. Occasionally, telescopes catch glimpses of bright spots, storms rising from deeper layers, glowing briefly before fading back into quiet. The planet's atmosphere, cool and sluggish, moves to a slower tempo, as though time itself thickens there. Uranus's magnetic field adds to its strangeness. Unlike Earth's, which aligns closely with its axis of rotation, the magnetic field of Uranus is tilted at a sharp angle and offset from the planet's center. It wobbles and twists through space, creating a magnetosphere that lurches unevenly with each rotation. When the solar wind strikes it, the field bends and ripples like fabric in slow motion. Auroras shimmer near the poles, faint but real, delicate curtains of light dancing in a world that rarely sees sunlight. The field is a reminder that even in the deep cold of the outer solar system, energy flows quietly, unseen but constant. Orbiting Uranus are faint, dark rings and a collection of moons that echo the planet's mystery. The rings are subtle, thin bands of dust and ice circling close to the planet's equator, barely visible except when backlit by sunlight. They lack the brilliance of Saturn's rings, Yet their simplicity is elegant, quiet arcs tracing the planet's tilted motion. Beyond them drift at least 27 known moons, each with its own history, each shaped by the strange geometry of Uranus's orbit. Among these moons are worlds of frozen beauty. Miranda, one of the smallest, is a patchwork of cliffs and valleys, its surface marked by fractures so deep they plunge 12 miles down the tallest. Known in the solar system, it looks as though it has been torn apart and stitched back together, a mosaic of geological scars. Ariel and Umbriel show contrasting characters. Ariel, bright and youthful, covered in networks of canyons, while Umbriel is dark and ancient, cloaked in shadow. Titania and Oberon, the largest of Uranus's moons, are silent worlds of ice and rock, their surfaces scarred by impact and time. Together, these moons move like an entourage of frozen attendants, each one shaped by the same tilted destiny that defines their parent planet. The light that reaches Uranus is faint, only a fraction of what warms Earth. The sun appears as a small, pale disk in the distance, too weak to cast sharp shadows. Yet even in that dimness, Uranus glows softly, reflecting sunlight like frosted glass. Its seasons unfold with impossible slowness, each lasting more than 20 Earth years. For a human lifetime, the planet would seem almost unchanging. Its motion is too gradual to perceive, its storms too subtle to see evolve. Yet it turns nonetheless, always rolling, always tilting, its rhythm invisible but eternal. There is something profoundly tranquil about Uranus. It does not shout its presence with color or violence. It whispers. Its calmness is deceptive, but its beauty is unmistakable. It teaches us that not all motion is loud, and not all change is visible. The forces shaping this planet are gentle and vast, their timescales longer than memory. To stand near Uranus, if such a thing could ever be, would be to feel the immense patience of nature, the slow breathing of a world content to exist without witness. When Voyager 2 passed Uranus in 1986, it was the only spacecraft ever to visit. The images it returned showed a planet that seemed almost featureless, serene to the point of stillness. Many were disappointed by the lack of drama, but others saw in that calm a different kind of wonder, the realization that not all beauty needs spectacle. The quietness of Uranus is its defining character. It turns without fanfare, carrying its tilted axis through the cold expanse, indifferent to our need for noise. Yet with modern telescopes, we have learned that even this stillness hides dynamism, faint storms, subtle waves, hidden heat slowly leaking from its interior. Uranus is not lifeless, it is simply patient. The name Uranus comes from the ancient god of the sky, the father of Saturn and grandfather of Jupiter, a fitting name for a planet that embodies the stillness of the heavens themselves. To look at it is to look into distance, not just in space, but in time. Its bluish glow seems eternal, as though it has always been there, watching quietly from the edge of the solar system. It reminds us that the universe does not rush, that its beauty often lies in restraint. Imagine now drifting near Uranus, floating above its faint rings. Below you, the planet glows softly, its surface a smooth gradient of teal and turquoise. The rings shimmer like strands of silk against the black. The sun hangs far away, no brighter than a lamp seen through fog, and around you stretches silence, deep, endless, absolute. You can feel the planet's slow rotation beneath you, sense the pull of its tilted gravity, the rhythm of its roll through space. It is a rhythm not measured in minutes or hours, but in centuries, a cosmic turning that continues without pause. As you close your eyes, let Uranus's calm settle over you. Feel its unhurried spin, its pale light, its patience. This is the music of distance, the song of a planet that moves at its own pace, untouched by the urgency of time. In its slow roll through the dark, Uranus reminds us that stillness, too, is motion, and that even the quietest worlds have their own gravity, subtle, steadfast, and endlessly beautiful. 14. Neptune, the deep blue wind. At the farthest edge of the known planets, where the sunlight is little more than a faint shimmer, and the cold becomes almost absolute, Neptune turns slowly in the dark. It is a world of deep sapphire and shadow, a planet that hums with invisible energy, even as it floats through the silence of space. Seen from afar, it glows with a color unlike any other, a vivid, haunting blue that seems to absorb the darkness around it and transform it into light. Neptune is the last great giant of our solar system, the farthest planet circling the Sun, and yet it feels alive with motion. Where Uranus whispers, Neptune sings softly, endlessly, through the wind. Discovered only in the 19th century, Neptune was found not by sight, but by mathematics. Astronomers noticed that Uranus was not moving quite as predicted, and from those subtle discrepancies, they calculated that another planet must be tugging at it from beyond. The numbers pointed to a specific place in the sky, and when telescopes turned there, Neptune was waiting silent, immense, and already glowing. It was as if the planet had allowed itself to be found only when we had learned enough patience to look for it properly. Neptune's atmosphere is both delicate and fierce. Like Jupiter and Saturn, it is made mostly of hydrogen and helium, but its blue hue comes from methane gas high in the clouds, which absorbs red light and scatters blue. Deeper still, unknown chemicals and complex aerosols give the planet a richness of tone, a depth of color that shifts subtly as sunlight passes through. The upper atmosphere is cold, nearly -220 degrees Celsius, but beneath it lies a restless world of storms and jet streams that move faster than any other in the solar system. Winds there race at over 2,000 kilometers per hour, faster than the speed of sound. These are the swiftest winds known, circling the planet in patterns of pure energy, invisible but relentless. Despite that ferocity, Neptune is a world of balance. Its storms rise and fade with grace, forming patterns that seem almost artistic in their symmetry. The most famous of these is the Great Dark Spot, a vast oval storm that once raged across its surface, discovered by Voyager 2 inches 1,989. Unlike Jupiter's Great Red Spot, which has persisted for centuries, Neptune's storms appear and disappear within decades, forming anew as the planet shifts its internal energy outward. The Great Dark Spot was once as large as Earth, swirling in a sea of pale blue. Yet when the Hubble Space Telescope looked again a few years later, it had vanished, dissipated into stillness. Then, years after that, another appeared, as though Neptune were breathing, exhaling storms from its depths, and then letting them go. Beneath its atmosphere, Neptune hides layers of mystery. The pressure deep within is so intense that ordinary molecules are transformed into exotic forms. Water and ammonia may exist there as hot, dense fluids, neither liquid nor gas, conducting electricity in ways that generate powerful magnetic fields. Some scientists believe that in those depths, carbon is compressed into diamonds that fall like rain, sinking slowly toward the core. Imagine that, a place where storms of gem-like drops shimmer in the dark, each one a spark of solid light tumbling through blue fire. It is a vision of strangeness and beauty, the universe reminding us how creative it can be, even in the coldest places. Neptune's magnetic field, like Uranus's, is tilted and offset from the planet's center. It twists and wobbles as the planet rotates, creating auroras that flicker faintly near the poles. These are not the dazzling curtains of Earth, but soft glows, pale veils of light rippling above the blue. unseen by any eye except those of passing machines. They are the whispers of the solar wind brushing against Neptune's magnetic breath, the outermost reach of our sun's influence still dancing at the edge of darkness. Around Neptune move faint rings and a family of moons. The rings are dim, composed of dark dust and ice, almost invisible, except when caught by sunlight at just the right angle. They are the faint echoes of shattered moons, particles gathered by gravity into thin arcs that circle in obedience to the planet's pull. But it is Neptune's largest moon, Triton, that holds the greatest mystery. Triton orbits in the opposite direction of Neptune's rotation, a sign that it was once a wanderer, perhaps a captured world from the Kuiper belt, drawn inward long ago by Neptune's gravity. Triton is one of the coldest known objects in the solar system, its surface coated in nitrogen ice that glows faintly pink under distant sunlight. Yet even there, in that frozen quiet, there is motion. Geysers of nitrogen burst from its surface, spraying icy plumes miles high into the air before they fall back like snow. Beneath its crust, there may lie another hidden ocean, warmed by the slow flexing of Neptune's tides. Even at the edge of the sun's reach, water may still move, still whisper, still dream. Neptune's orbit takes it nearly 30 times farther from the sun than Earth, and yet the light that reaches it still transforms it into beauty. The sun, seen from Neptune, is no larger than a small bright star, yet its light is enough to make the planet glow with a deep inner radiance. It is easy to imagine Neptune not as a planet, but as a living wave, a great rolling motion that carries the memory of creation outward into space. It turns slowly, completing one rotation every 16 hours, its day marked not by sunrise or sunset, but by the shifting of faint storms and the drift of high, thin clouds. Its year lasts 165 Earth years. A single season could span a human lifetime. Voyager 2's encounter with Neptune in 1989 remains one of the most poetic moments in the history of exploration. As the spacecraft passed the planet, it captured images of swirling blues and streaks of white methane clouds moving at impossible speed. For a brief moment, we saw the farthest world up close, its storms alive with movement and light. When Voyager left Neptune behind, it carried with it the last of humanity's first-hand views of the planets, the final frontier of the classical solar system. Since then, Neptune has been watched only from afar, its voice faint but constant, its winds still singing through the vacuum. Neptune's beauty lies in contrast: motion within stillness, heat within cold, presence within distance. It is a world where everything moves too slowly or too fast for the human eye to follow. Its winds travel at unimaginable speeds, yet its seasons unfold over centuries. It reminds us that time and energy are not opposites, but partners, that even in the quietest reaches of space, there is movement too vast for us to feel. Neptune is the universe's whisper of power, invisible, enduring, and immeasurable. If you were to drift above Neptune's clouds, you would see no solid surface below, only the endless layering of color, deep blue fading into violet, streaked with faint white storms. The air would rush past faster than sound, carrying with it traces of methane and ice. The sun would hang as a distant spark, casting the faintest light across the horizon. All around, the planet would hum with motion, invisible waves of magnetism and wind moving through the darkness. It would feel both alien and infinite, like standing at the edge of a living sea that has no shore. As you close your eyes, imagine Neptune turning slowly beneath that faraway light. Picture its clouds swirling in silence, its winds circling the globe, its faint rings tracing luminous threads through the dark. It is the farthest planet, the quiet guardian of the outer solar system, where heat becomes memory and motion becomes peace. Neptune moves with purpose, though it seems to drift, carrying the rhythm of the sun even into the shadows, where the light no longer reaches. It is the planet of the deep blue wind, a reminder that even at the edge of night, the universe still breathes, still moves, still sings. 15. Pluto, the heart of ice and memory. At the outermost reaches of the sun's gentle reach, where its light fades into a silver whisper and the stars reclaim their dominance, there drifts a world that once marked the edge of the known. Pluto, small and cold, moves through that distant darkness in quiet grace. It is neither fully planet nor merely rock, but something in between, a remnant of the solar system's beginning, preserved in solitude. Though it was once called the 9th planet, Pluto has never seemed diminished by names. It is a world of its own making, patient, secretive, and beautiful in ways that defy category. From afar, Pluto appears as a tiny point of light, pale and elusive. For most of human history, it was invisible to all but the most powerful telescopes. It was discovered not by accident but by persistence, the careful work of watching the heavens and noticing the faint, slow drift of something that should not have been there. When Clyde Tombaugh found it in 1930, it was more an idea than an image, a moving speck at the edge of the map. Since then, Pluto has grown in the imagination as much as in our knowledge, a symbol of distance, of mystery, of the quiet persistence of the unknown. It was not until the summer of 2015 that we truly saw Pluto for the first time. The spacecraft, New Horizons, after traveling more than 9 years through space, passed close enough to capture its surface in astonishing detail. What it found astonished even those who had dreamed of it longest. Pluto was not a frozen ruin, but a living world, scarred and sculpted by processes that still continue today. Mountains of ice rose higher than the Rockies, vast plains stretched smooth and bright, and valleys cut across the surface like veins. Its colors were subtle creams and tans and faint reds, as though the planet were blushing beneath the cold. And at its center, glowing like a symbol of defiance, was a vast, heart-shaped plain. This region, named Tombaugh Regio after its discoverer, is Pluto's most famous feature, a smooth expanse of frozen nitrogen ice that spans more than 1,000 kilometers. The left side of the heart is a vast basin called Sputnik Planitia, where the ice is so deep that it flows slowly, like glaciers on Earth. Convection currents within it create patterns that resemble giant cells, as though the surface itself were breathing in slow motion. This heart is not still, it shifts, moves, and renews itself, erasing craters and smoothing the land. It is a reminder that even at the edge of the sun's warmth, the universe remains alive with movement. Pluto's surface is a study in contrasts. Some regions are rugged, dark, and ancient, covered with craters that have endured for billions of years. Others are young, bright, and fresh, renewed by unknown forces from below. Its mountains are made of water ice, frozen so hard in the frigid cold that they stand as firmly as stone. Its plains are composed of softer ices, nitrogen, carbon monoxide, methane materials that flow and change with the faint warmth that reaches them. The boundaries between these terrains look like brushstrokes, the mark of time and temperature blending one into the other. The temperature on Pluto averages around -230 degrees Celsius. In that cold, gases freeze solid, and the sunlight that touches the ground is 1,000 times weaker than on Earth. And yet, even there, energy moves. The thin atmosphere, composed mainly of nitrogen, expands and contracts as Pluto travels along its long, elliptical orbit. When it moves closer to the sun, its ices sublimate, creating a thin, ghostly haze that rises into the sky. When it drifts farther out, the atmosphere collapses, falling back as frost upon the land. This breathing of gas and ice gives Pluto a rhythm, a slow, patient pulse that marks its year. which lasts 248 Earth years. Above this, fragile atmosphere. The sky glows faintly blue, a surprise that New Horizons revealed when it looked back toward the Sunday. The color comes from tiny particles called tholins, complex organic molecules formed when ultraviolet sunlight interacts with methane. These particles drift downward through the air, coating the surface with a reddish tint. It is this subtle blush that gives Pluto its warmth of tone, a quiet hint of color in a place where color should not be. In its way, the planet paints itself anew with every orbit, a living canvas of chemistry and time. Pluto's moons move around it in delicate synchrony. The largest, Charon, is so big relative to Pluto that the two worlds orbit a common point in space, making them a true binary system. Charon's surface is rougher and darker, marked by canyons and cliffs that cut deep into its crust. A vast chasm runs across its face deeper than the Grand Canyon, hinting at ancient expansion and cracking as its interior froze. Two bodies are tidally locked, always showing the same face to one another, turning together like a pair of dancers in slow motion. To stand on Charon and look up at Pluto would be to see it hanging motionless in the sky, a world with a glowing heart shining faintly through a haze of nitrogen light. The smaller moons Styx, Nix, Kerberos, and Hydra are irregular, tumbling through space in unpredictable ways. They are fragments of a greater story, likely born from a collision long ago, when an impact shattered Pluto's surface and cast debris outward to form this family of moons. Their orbits are chaotic yet stable, like notes in a melody that never repeats. Together, they complete the composition of Pluto's world, a quiet harmony of motion at the edge of light. When we think of Pluto, it is tempting to think of loneliness. It lies so far from the sun that light takes more than 5 hours to reach it. The stars from its surface would shine with a brightness that feels eternal, unblinking, unchanging. Yet loneliness is not the right word. Pluto is distant, yes, but not empty. It belongs to a greater realm, the Kuiper Belt, a vast ring of icy bodies that stretches beyond Neptune. Here, countless worlds drift in slow orbits, remnants of the solar system's formation, each one carrying traces of the same materials that built the planets. Pluto is their ambassador, the first to be seen up close, the voice of a region that speaks in whispers of ancient time. In Pluto's stillness, there is wonder. It reminds us that warmth is not the only measure of vitality, that even in the deepest cold, patterns form, movement continues, and beauty persists. It teaches us that the universe does not forget its beginnings. It preserves them, carries them outward, lets them drift where light is faint but meaning endures. When New Horizons passed beyond Pluto, it looked back one last time and saw the planet's silhouette framed by sunlight, its thin atmosphere glowing like a halo. For that brief moment, Pluto shone brighter than ever before, a small, distant world illuminated by its own reflection of the sun's eternal light. As you drift into sleep, imagine Pluto turning slowly at the edge of the solar system. The sunlight touches its heart-shaped plane, faint but constant, scattering off the frozen nitrogen like a sigh. Charon circles beside it, bound by invisible threads of gravity. Around them, the Kuiper Belt stretches endlessly, filled with silent travelers made of ice and memory. The darkness here is soft, not empty, filled with the slow motion of creation's remnants still keeping time with the Sunday. Pluto drifts within that silence, patient, enduring, its heart shining faintly in the cold, a reminder that even at the farthest edge of night, love, warmth, and wonder still remain. 16. The Kuiper Belt, the solar system's silent frontier. Beyond the orbit of Neptune, beyond even the slow turning of Pluto's distant path, lies a realm where sunlight fades into a soft gray whisper, and the solar wind weakens into calm. It is the Kuiper Belt, a vast, silent frontier, encircling the sun like a faint halo of frozen debris. Here, the solar system begins to dissolve into the interstellar dark. The space between objects grows immense, the temperature falls near absolute zero, and time itself seems to slow. Yet even here, at the farthest edges of our sun's reach, there is motion, there is memory, and there is beauty. The Kuiper Belt is not empty. It is filled with the fragments of beginnings, the unspent material of creation still drifting after 4.5 billion years. To imagine the Kuiper Belt is to imagine a vast ring of ice and rock stretching from about 30 to 55 times the distance between Earth and the Sunday. It is a region wider than all the inner planets combined, populated by millions of frozen bodies, some as small as mountains, others large enough to be worlds in their own right. These objects, known as Kuiper Belt objects, or KBOs, are remnants of the early solar system, the leftovers that never coalesced into planets. They are ancient, unaltered, and patient, circling the sun in slow, stable orbits that may last for millions of years. Each one carries within it a record of the solar system's youth, a chemical memory of what the universe was made of when the planets first took shape. The Kuiper Belt is often called the solar system's attic, a place where fragments of its childhood have been stored and preserved. Yet that metaphor feels too static, too simple. This is no still warehouse of ice. It is a slow-moving river of countless objects, each turning softly in the dark. Occasionally, gravitational nudges from Neptune send one of these bodies inward, transforming it into a comet that travels toward the sun, its ice sublimating into a glowing tail as it passes through the warmth of the inner system. Each comet that visits Earth's sky carries with it a trace of the Kuiper Belt, a small, luminous messenger from the solar system's forgotten edge. Among these drifting worlds, Pluto is the most famous, but it is far from alone. Others like Haumea, Makemake, and Eris share its distant domain. Each is unique, shaped by its own slow dance through the cold. Haumea spins so rapidly that it is stretched into an oval, its icy surface glinting with crystalline frost. Makemake glows faintly red, its color shaped by organic molecules frozen into its crust. Eris, once considered Pluto's twin in size, is a gleaming, distant world that orbits far beyond, sometimes coming closer to the sun than Pluto, sometimes traveling almost twice as far away. Together they form a scattered family, each one a fragment of an unfinished story, a world born too small or too distant to gather enough heat or gravity to grow further. The Kuiper Belt is quiet, but not lifeless. It is filled with subtle light sunlight reflecting off countless icy surfaces, creating a faint glow that can be seen from Earth on the darkest nights, known as the zodiacal light. It is the whisper of creation, still echoing through the dark. In this way, the Kuiper Belt forms the solar system's soft outer boundary, a bridge between the worlds we know and the infinite unknown beyond. Beyond even this region lies the Oort cloud, a vast, spherical shell of icy debris that may extend halfway to the nearest stars. But the Kuiper Belt is closer, more tangible, the threshold between what we have touched with our machines and what remains untouched forever. When the New Horizons spacecraft left Pluto behind, it did not stop. It continued its journey into this silent region, becoming the first human-made object to explore the Kuiper Belt up close. In 2019, it passed a small, icy body called Arakoth, a contact binary shaped like two spheres joined together, drifting through the dark as one. The images sent back showed a world of soft contours, colored in warm red hues, untouched since the solar system's birth. Its surface bore no scars of violence, only the quiet patterns of accumulation. It looked peaceful, almost delicate, like something sculpted by time rather than impact. In Arakoth's gentle form, scientists saw a clue to how planets once began small objects merging slowly, drawn together by gravity's patient hand. Here, the sun is a distant lantern. Its light reaches these faraway worlds more than 6 hours after it leaves the solar surface, and when it arrives, it is weak, barely enough to illuminate the ice. The stars are sharper here, undimmed by any atmosphere. Space feels heavier, filled with the quiet presence of distance, and yet there is warmth in the faint light that remains, not heat, but the warmth of belonging. The knowledge that even here, 90 billion kilometers away, the sun still matters. Its gravity still holds sway. Its glow still reaches, and its pull still defines the rhythm of orbits. In the Kuiper Belt, time flows differently. The sun rises and sets with agonizing slowness, and a single year may outlast an entire human civilization. The surface of an icy body here changes so rarely that a single impact may remain visible for 1 billion years. The winds of history do not blow, only the light moves, slow and steady. It is in this near timelessness that the Kuiper Belt's beauty resides. Every object here is a message from the solar system's dawn, unchanged, uncorrupted by the passage of eons. If we could read them, we would find written within their frozen layers the chemistry of creation itself: water, methane, ammonia, carbon compounds, and traces of the first organic molecules. In their silence, these worlds remember everything. To drift among the objects of the Kuiper Belt would be to experience absolute serenity. There is no sound, no air, no storm. The only motion is the gentle turning of one world around another, the quiet sweep of orbits that repeat without hurry. If you look toward the sun, you would see it as a brilliant star, brighter than any other, but no longer dominating the sky. Around you, countless small worlds would glimmer faintly, like distant lanterns on a frozen sea. Gravity would be weak, the pull between objects slight but steady, like invisible threads connecting everything in a vast, fragile web. It would feel almost sacred, a place beyond time, where creation has settled into peace. And yet, for all its distance, the Kuiper Belt is not separate from us. Every comet that falls inward, every meteor that crosses our skies, every whisper of dust that drifts through Earth's atmosphere may have begun its journey here. In this sense, the Kuiper Belt is part of our story, a source of water, carbon, and life's earliest ingredients. The oceans of Earth may owe their existence to ice that once drifted through this very region. Our blood, our breath, our cells may carry atoms that first froze in the Kuiper Belt, billions of years before the sun's light ever reached our world. It is humbling to realize that even the farthest edges of the solar system are connected to us, that the boundary between the known and the unknown is not a wall, but a continuum. The Kuiper Belt is not an end. It is a threshold, the last quiet meadow before the forest of stars. It is the place where the sun's voice fades but does not vanish, where gravity still holds but softly, where light still travels but takes its time. Beyond it lies interstellar space, where the sun becomes just another star in the vast, unbroken dark. As you close your eyes and drift into rest, imagine the Kuiper Belt stretching endlessly outward. Picture its small, frozen worlds turning gently under a dim golden star. The silence there is complete, yet filled with memory, the echoes of creation still drifting in their endless paths. The light moves slowly, the shadows linger, and time holds its breath. In that silence, the universe is neither young nor old, it simply is. And within that stillness, even at the edge of everything we know, there remains connection, warmth, and wonder. The sun's faint light glows softly on ice that has never melted, and in that glow, the story of the solar system continues, patient as the stars, eternal as the dark. 17. The Oort cloud, the edge of the sun's dominion, beyond the Kuiper belt, where even the faint whisper of sunlight becomes a thread stretched thin through the dark. There exists a realm that marks the final boundary of the sun's touch. It is not a place one could point to easily, nor a ring like the planets that circle in defined paths, but a great spherical shell surrounding everything we know, a distant halo of ice and memory that encases the solar system in silence. This is the Oort cloud, the edge of the sun's dominion, where the influence of our star fades into the gravitational embrace of the galaxy itself. It is the outermost breadth of the solar system, a place so remote that the light of the sun takes almost a year to reach its farthest reaches. The Oort cloud is not a world, nor even a belt of worlds, but a vast congregation of comets, trillions of icy bodies scattered across a region so wide it defies comprehension. It begins perhaps 2,000 times farther from the sun than Earth, and stretches for light years into space. Each tiny fragment within it is a survivor from the dawn of time, born near the sun and flung outward billions of years ago by the gravitational dances of the giant planets. What was once the dust and frost of creation now drifts at the very edge of interstellar space, waiting, sleeping, in darkness so deep that 1,000 suns could pass unseen. No human eye has ever seen the Oort cloud directly. It is too far, too faint, its members too small to reflect meaningful light. Yet, its presence is certain. We know it exists because some of its exiles return. When a distant comet appears in our skies, a bright, luminous traveler with a tail of ice and gas stretching across the heavens, it is almost always a visitor from this outer shell. These comets are wanderers that have been dislodged from their long orbits, perhaps by the passing of a nearby star or the subtle tug of the Milky Way's tidal forces. After millions of years of slumber, they fall inward toward the sun, warming, glowing, shedding their frozen skin in luminous trails. Each one is a message from the Oort cloud, a fragment of the solar system's infancy briefly rekindled in light. In this way, the Oort cloud is a memory the solar system's archive written in ice. Its countless objects preserve within them the chemistry of the earliest sun, frozen snapshots of what existed before Earth, before life, before even the planets had formed. They are the purest relics of the solar nebula, untouched by heat or time, unchanged for billions of years. If we could touch one, we would be touching the beginning itself material that predates oceans, continents, and all living breath. The Oort cloud is the universe's way of remembering, a great vault of origins suspended in the endless dark. Though it feels distant, the Oort cloud is not separate. It is bound still by the sun's gravity, faint but persistent, like a whisper that carries farther than sound should travel. Every particle in that shell, every frozen world, still moves in orbit around the sun, though their years are counted not in centuries or millennia, but in millions. One orbit might outlast entire epochs of evolution on Earth. A comet that falls inward today may not return again until the shapes of the continents have changed, until mountain ranges have risen and eroded back into the sea. The Oort cloud moves in the language of deep time, where the smallest motion takes eons to complete. It is likely that the Oort cloud is not perfectly smooth, but layered and textured, an inner cloud mingling with the Kuiper belt, and a distant outer region extending nearly halfway to the nearest stars. The sun's domain blends with that of others, the edges overlapping like the faint halos of neighboring lights in a vast cosmic night. From within this shared border, comets may occasionally drift from one system to another, crossing between stars as seeds of ice and dust. It is possible that some of the comets that visit Earth began their journeys around suns long extinguished, and that some fragments from our own Oort cloud have already begun new orbits around distant stars. The boundary between solar systems is not a wall, but a shared breath, the galaxy's quiet way of exchanging memories. In the cold vastness of the Oort cloud, there is no sound, no warmth, no light, except what starlight can offer. The sun appears as a brilliant star, no larger than a pinprick, surrounded by the endless dark. The nearest objects are so far apart that one could travel for lifetimes without seeing another. And yet, in their isolation, there is a quiet comfort. Each frozen body is steady, stable, in orbit, with infinite patience. The emptiness is not loneliness, it is peace, a peace so complete that time itself seems to stop listening. When a comet's long sleep is interrupted, the journey inward is both violent and magnificent. As it falls toward the sun, the faint warmth awakens it. Ice turns to vapor, dust lifts into space, and tails of light stretch for millions of kilometers. For a few brief weeks or months, it becomes visible even from Earth, a glowing wanderer tracing the path of its long ellipse before fading again into night. To us, it is a spectacle, but to the Oort cloud, it is only a heartbeat, a single pulse in the rhythm of eternity. Then, as its momentum carries it back outward, the comet cools, still glowing faintly. Returning to its place among the sleeping billions, its orbit reset for another eon of rest. Scientists believe that the Oort cloud formed in the solar system's earliest days, when the giant planets were still shifting in their positions. As Jupiter and Saturn grew massive, their gravity acted as catapults, hurling countless icy bodies outward into the dark. Some escaped entirely, flung into interstellar space, while others slowed just enough to remain bound to the sun, settling into distant, elongated orbits. Over time, the gravity of passing stars and the galactic tide rounded those orbits into a sphere. What remains today is a cloud that stretches far beyond vision, a spherical sea of frozen relics, still anchored faintly to the star that birthed them. It is the outermost boundary of the sun's influence. Beyond this, space belongs not to any one star, but to the galaxy itself. If you could stand upon one of those icy bodies, though there is no standing in such a place, the view would be haunting. The stars would crowd the sky in impossible clarity, brighter and sharper than anything seen from Earth. The sun would appear as a solitary, golden speck among billions, indistinguishable except by its warmth. The silence would be total, so deep that even your thoughts might seem to fade into it. And yet, despite the isolation, there would be connection. That distant speck of light, that small golden star, would still be home. Its gravity would still hold you. Its light would still define your shadow. Even here, at the edge of everything, you would remain part of the sun's great family. The Oort cloud is not merely a boundary of distance. It is a boundary of imagination. It marks the place where the known dissolves into the unknown, where our solar system blends into the cosmic sea. To cross it would be to leave home in the truest sense, to pass from the warmth of a single star into the endless communion of all stars. And yet, as vast as it is, it remains within the same fabric of creation. The atoms that form its ices are the same as those that form you. The gravity that holds its bodies is the same that holds your feet to Earth. Distance changes nothing of connection. It only stretches it thin until it becomes light. As you drift toward rest, imagine the Oort cloud encircling everything, a soft, invisible shell made of the oldest ice, glimmering faintly in starlight. Picture its quiet orbits, its frozen travelers turning slowly in the dark. The sun at the center still burns, though its warmth barely reaches them, a faint pulse in the great silence. Beyond the Oort cloud lies the void between stars, but here, on its inner edge, the memory of light still lingers. Every comet, every frozen grain, still belongs to the sun, still dances in its rhythm. In that vastness, there is no ending, only expansion, only continuity. The Oort cloud is the final whisper of home, a boundary not of separation but of serenity, where the solar system exhales into the cosmos and becomes one with the night. 18. The heliosphere, the sun's invisible shield. Around every flame there is a calm, breath, a boundary where heat meets coolness, where light fades gently into dark. Our sun, too, has such a boundary, not one that can be seen, but one that can be felt in the movement of invisible winds. This vast, unseen envelope surrounds the entire solar system, stretching far beyond the orbit of Pluto, far beyond the drifting edge of the Kuiper belt, until it finally blends with the interstellar medium between the stars. It is called the heliosphere, the sun's invisible shield, a great bubble of charged particles and magnetic fields that travels with our star as it sails through the galaxy. Within it, all the planets are sheltered, their sky is shaped and protected by the steady breath of the Sunday. The heliosphere begins in the heart of the sun, where nuclear fusion burns ceaselessly, fusing hydrogen into helium and releasing light and energy. Along with photons, the sun also emits a constant flow of charged particles, electrons, and protons, known as the solar wind. This wind streams outward in all directions, carrying the sun's magnetic field with it. It moves silently, without friction, filling the vast space between the planets. Though thin and nearly weightless, it moves with astonishing speed, sweeping past Earth at nearly 800 kilometers per second. Every moment of every day, this solar wind passes through you, through the air, through everything on our planet, unseen but omnipresent. As it travels outward, the solar wind slowly loses strength, billions of kilometers from the sun, where the wind's pressure finally equals the opposing pressure of interstellar space. The edge of the heliosphere is formed. This boundary is called the heliopause, the point where the sun's influence yields to the vast currents of the galaxy. Inside lies the familiar space of the planets. Beyond lies the true interstellar medium, filled with cosmic rays, magnetic turbulence, and the faint whisper of other stars. The heliopause marks the frontier between whisper, home, and the beyond, the final threshold of the sun's reach. The heliosphere is immense, stretching more than 100 times farther from the sun than Earth does. Yet, it is not a perfect sphere. It is shaped and sculpted by motion, by the sun's rotation, by its magnetic fields, and by its travel through the galaxy. The solar wind forms a kind of comet-like tail behind it, where the sun's motion through interstellar space stretches the bubble outward. In front, the heliosphere compresses against the oncoming flow of the galactic wind. Its shape is fluid and ever-changing, a living boundary that breathes with the sun's rhythm. For all its invisibility, the heliosphere is one of the most important features of our solar system. It shields the planets from much of the high-energy radiation that fills interstellar space. Without it, the constant barrage of cosmic rays would strip away atmospheres, damage organic molecules, and alter the delicate chemistry of life. Heliosphere is a kind of cosmic cocoon, a bubble of relative calm in a turbulent sea. It is the reason Earth's sky can hold clouds, instead of being etched by endless streams of ionizing light. The same wind that paints auroras at the poles also guards the very possibility of life below. The boundary regions of the heliosphere are strange and beautiful. At a certain distance, where the solar wind slows abruptly as it meets resistance, lies a region called the termination shock. Here, the wind's speed drops below the speed of sound, forming waves and eddies of magnetic energy. Beyond that lies the heliosheath, a turbulent zone where solar and interstellar particles mingle. This is the frontier of two winds, two spaces, the breath of the sun meeting the breath of the galaxy. Beyond the heliopause, the interstellar wind takes over, carrying dust and gas that have drifted between the stars for billions of years. It is here that the sun's story ends and the galaxy's begins. Two spacecraft, launched long ago, have crossed this invisible border, Voyager 1 and Voyager 2. They were born of our curiosity and our need to understand where we live in the cosmos. Launched in the late 1970 seconds, they toured the outer planets before continuing outward, silently and steadily, toward the edge of the Sun's domain. Voyager 1 crossed the heliopause in 2012. Voyager 2 inches 2018. Their instruments recorded the moment when the density of interstellar particles began to rise, when the pressure of the solar wind fell silent. The data showed what no human had ever known directly, that the heliosphere does not end abruptly, but fades gradually into the galaxy, like the dying echo of a song. Though their signals now take more than 22 hours to reach Earth, the Voyagers still speak. They are our emissaries to the interstellar sea, still floating within the faint reach of the Sun's light. When they crossed the boundary, they carried with them messages from humanity, the golden records, filled with music, images, and greetings in many languages. These records, affixed to their sides, contain the sounds of Earth, thunder, birdsong, the rush of waves, the laughter of children, the voices of our species reaching outward. If another civilization ever finds them, they will hear what it was like to live within the heliosphere, to be cradled by the breath of a star. Inside this vast bubble, the solar wind connects everything. When a flare erupts from the Sun's surface, it sends ripples through the heliosphere that reach Earth in days, Jupiter in weeks, and the outer planets in months. These waves of energy shape auroras, disrupt magnetic fields, and carry with them information about the Sun's mood. Even at the edge, the Voyagers still feel these ripples, the soft tremors of the Sun's heart, stretched across billions of kilometers. The heliosphere is not empty space. It is the medium of connection, a continuous fabric of energy that ties the pre-full planets and their moons to the same pulse of light. To stand outside it, if such a thing were possible, would be to feel the difference between home and the wild. Inside, the particles flow in rhythm, aligned with the Sun's magnetic field. Outside, they come from every direction, chaotic and ancient, born of distant stars and supernovae. The heliosphere is our star's way of maintaining order within its reach, of creating a safe harbor against the cosmic storm. It is a testament to the Sun's enduring vitality that even across distances so vast, its influence continues to shape the space it inhabits. The heliosphere moves with the Sun through the galaxy like a ship carrying its own atmosphere. As the Sun orbits the Milky Way every 200 million years, the shape of its bubble changes with the currents it encounters. Sometimes it compresses under pressure from dense clouds of gas. Sometimes it expands into more open regions. In this way, the heliosphere is both a shield and a sail, adapting as our solar system drifts through its long voyage around the galactic center. It is comforting to think that every world we have ever known, every moon, every comet, every atom of air you have ever breathed, exists within this shared boundary, this great breath of the Sunday. It reminds us that we are not isolated. Even the most distant planet, even the coldest fragment of ice in the Kuiper Belt, still lies within the warmth of the Sun's protection. We are all carried together inside this invisible sphere, moving quietly through the dark sea of stars. As you close your eyes, imagine that vast bubble, the heliosphere, glowing faintly against the backdrop of the Milky Way. Inside it, the planets turn, their orbits like soft ripples around a golden heart. The solar wind flows outward, steady and eternal, its particles tracing invisible paths through the quiet vacuum. At the edge, the winds meet, bowing gently to one another before fading into unity. This is the breath of the Sun, expanding, protecting, continuing without end. And within that breath, we drift small, luminous, alive, cradled in the light of a star that has never stopped reaching out to touch the dark. 19. the interstellar medium, the sea between the stars. Beyond the invisible boundary of the sun's reach, past the edge of the heliosphere, where its winds fade into stillness, begins the vastness of the galaxy, the true space between the stars. Here lies the interstellar medium, an ocean so thin and so quiet that it might seem like emptiness. Yet within it flows the material from which all stars and planets are born. It is not a void, but a veil, filled with dust, gas, and ancient light, a sea of atoms and particles drifting endlessly through the Milky Way. Though it appears silent, this space hums with unseen energy, the faint afterglow of a billion suns mingling in the dark. The interstellar medium is the connective tissue of the galaxy, the breath between its stars. It is composed primarily of hydrogen and helium, the simplest and oldest elements, sprinkled with traces of carbon, oxygen, nitrogen, and iron. These atoms float far apart, so far that a single cubic centimeter of space may hold only a few molecules. Yet across the unimaginable distances between stars, they gather meaning. Every wisp of gas, every speck of dust, plays a role in the endless cycle of birth and death that governs the galaxy. Stars form from these clouds, live their brilliant lives, and return their ashes to the same medium from which they came. The interstellar space is therefore not a place of nothingness, but of becoming a slow, ceaseless transformation that spans eons. The gas of the interstellar medium exists in many states, some cold and dense, where molecules cling together to form clouds, opaque even to starlight, and others hot and thin, where atoms drift freely, ionized by the radiation of nearby stars. These regions shift and blend, stirred by shock waves from supernovae and shaped by the magnetic currents that wind through the Milky Way. Some clouds glow softly in infrared or ultraviolet, their atoms excited by light. Others are dark and hidden, blocking the stars beyond them from view. Through this vast interplay of light and shadow, the galaxy breathes. Each cloud, each filament of dust, is both destruction and creation, a cradle for future suns, a grave for the remnants of old ones. If one could travel through the interstellar medium, the experience would be paradoxical. To the eye, there would be almost nothing, a darkness so complete that stars would appear as piercing points of white scattered through black infinity. Yet in that darkness, every atom would carry a story. Each particle of dust may have once been part of a planet's crust or the heart of a dying star. Every wisp of hydrogen might someday fall into gravity's grasp and ignite, becoming part of a newborn star. The airless silence is deceptive. It hides the slow alchemy of galaxies, the process by which the universe renews itself without end. The interstellar medium is not uniform. It forms great, rippling structures across the Milky Way, vast bubbles, filaments, and cavities carved by the energy of stars. When a massive star reaches the end of its life and explodes as a supernova, its shockwave travels outward at thousands of kilometers per second, compressing and sculpting the gas around it. These waves overlap and collide, forming new clouds where gravity can take hold once more. In this way, death becomes creation. The atoms expelled by one generation of stars seed the birth of the next. The carbon in your body, the oxygen in your lungs, the iron in your blood, all were once part of this interstellar medium, carried through space before finding a home in the sun and in the earth beneath you. Within this sea between stars drift delicate grains of dust, microscopic fragments of carbon, silicates, and frozen molecules. They are the building blocks of planets and life, the seeds of chemistry that travel between systems. Though they are small, their collective influence is immense. They scatter and absorb starlight, shaping the color of the night sky. When you see the dark bands of the Milky Way stretching across the heavens, You are looking at the shadows cast by interstellar dust, the places where stars hide behind curtains of ancient material. These grains float for billions of years, changing slowly, gathering layers of ice and carbon, before being drawn into the gravitational pull of a new star-forming region. In time, they may become part of a world once again, perhaps even a world like ours. The interstellar medium is filled not only with matter, but also with invisible forces. Magnetic fields thread through it, guiding the motion of particles like unseen currents in an endless ocean. Cosmic rays, high-energy particles born in the explosions of distant stars, race through this space at near the speed of light, carrying with them traces of the events that created them. When they strike atoms in the interstellar gas, they trigger faint glows of radiation, subtle echoes that astronomers can read like fingerprints. Through these signals, we can glimpse the invisible, the structure of our galaxy, the flow of its energy, the quiet motion of its heart. In the spaces between the densest clouds, the interstellar medium becomes incredibly thin, so sparse that a spacecraft could travel for centuries without encountering a single atom, and yet it is never truly empty. Photons from distant stars fill it with faint light, and gravity ties it to the greater motion of the Milky Way. The galaxy itself rotates like a vast spiral disk, and the interstellar medium drifts with it, flowing between the stars as a slow, continuous current. The Sun, with all its planets and its protective heliosphere, is sailing through this ocean right now, moving through a region known as the local interstellar cloud, a patch of warm, diffuse gas roughly 30 light-years across. Every second, billions of atoms from this cloud slip into the heliosphere, merging briefly with the solar wind before being pushed away again. In this way, our solar system is never alone. It is constantly touching, exchanging, breathing with the galaxy around it. Though invisible to the eye, the interstellar medium glows faintly in radio and infrared light. With sensitive instruments, astronomers can trace the wisps of hydrogen and dust that stretch across thousands of light-years, mapping the hidden architecture of the Milky Way. These vast tendrils form the skeleton of the galaxy, the structure upon which stars and nebulae are hung like ornaments of light. To look at such a map is to see the galaxy not as a flat disk of stars, but as a living organism, its veins filled with the slow pulse of gas and radiation. It is in this unseen network that the story of creation continues to unfold, quietly, perpetually, without beginning or end. The beauty of the interstellar medium lies in its humility. It does not burn like a star or shine like a planet, yet it is the foundation for all of them. It is the quiet canvas upon which the light of the universe is painted. In its darkness lies the potential for every spark of light that will ever exist. To contemplate it is to realize that we are never truly separate from the rest of the cosmos. The same material that fills the void between stars flows through our veins and rests in our bones. We are, in every sense, made of the interstellar medium, shaped by the same dust and gas that wander between worlds. As you drift into sleep, imagine the sun moving slowly through this infinite ocean. Around it, the heliosphere glows faintly, a fragile bubble carried on the current. Beyond, the interstellar medium stretches in all directions, vast, calm, and endless. Clouds of hydrogen drift like cosmic fog, illuminated by distant starlight. The galaxy turns gently, its spiral arms sweeping through time, its stars kindling and fading like breaths. In this sea between the stars, everything is connected: light, matter, memory, and life. And as the Milky Way continues its slow rotation through the universe, we too drift with it, cradled within its quiet tide, part of the same story that began long before the sun and will continue long after it fades. 20. The cosmic night, where the solar system meets the stars. At the farthest edges of the sun's reach, where the last whispers of its wind fade into the calm sea of interstellar space, the solar system finally dissolves into the night. It is here, in this uncharted frontier, that the known and the unknown meet, a place where the warmth of our star becomes memory, and the light of distant suns begins to fill the sky. This is the cosmic night, the quiet expanse, where the boundaries between one system and another blur, where the silence deepens, until even the sound of thought feels like an echo. It is not an end, but a merging, the place where the solar system exhales and becomes part of the galaxy. The journey to this edge begins long before one arrives. As a traveler moves outward from the inner planets, the sun's light grows weaker, its heat fainter, its pull gentler. The worlds of Mercury, Venus, Earth, and Mars fall behind, their orbits glowing like embers in the distant dark. Beyond Jupiter and Saturn, the sunlight turns pale and thin, barely bright enough to cast shadows. Uranus and Neptune drift in sapphire calm, then give way to Pluto and the Kuiper Belt, a kingdom of ice and stillness. Beyond that, the Oort cloud glimmers invisibly, a soft shell of frozen relics suspended in near-eternal sleep. And past even that, the solar wind falters, losing its power to push against the greater tide. Here, at the edge of all that belongs to the sun, begins the cosmic night. The sun, seen from this distance, would no longer be a blazing disk in the sky, but a bright golden star, small enough to cover with a fingertip. Its light would still be strong enough to cast faint illumination on nearby ice, but its warmth would not be felt. Space itself would appear black and crystalline, filled with stars so clear that each one would seem to shimmer with meaning. You would be surrounded not by darkness, but by infinity, a boundless field of light and silence. Every star would have its own realm, its own planets, its own winds, its own story. The space between them would seem vast beyond comprehension. Yet even here, in this apparent emptiness, there would be connection, the faint threads of gravity and light that tie all things together. This region, where the solar system meets the stars, is not empty. It is filled with the residue of creation atoms, dust, and magnetic whispers drifting between the great stellar domains. Here, the sun's heliosphere merges with the interstellar medium, blending its boundary into the galactic sea. The solar wind gives way to the interstellar wind, and particles from distant stars begin to flow through our neighborhood. Cosmic rays, born from the explosions of supernovae, race through this space, carrying the signatures of stars that died billions of years ago. In this way, even the void between stars is alive, a slow exchange of energy and matter that never ceases. The universe, even in its quietest places, is always in motion. The cosmic night is not merely darkness, it is the purest form of stillness. There are no planets here to orbit, no moons to rise or set. There is no dawn or dusk, no sound or motion but the faint hum of radiation that fills every corner of the universe. Yet it is not lifeless. The photons that cross this space have traveled for eons, carrying the light of galaxies and the echoes of the Big Bang itself. The faint afterglow of creation, the cosmic microwave background stretches across all of space, a soft bath of ancient light, the final remnant of the universe's first fire. Even here, where the sun's presence fades, that light continues, wrapping the cosmos in a gentle warmth that has never completely vanished. To exist in the cosmic night would be to feel the scale of the universe in every direction. The nearest star, Proxima Centauri, lies more than 4 light-years away, 40 trillion kilometers of emptiness, of distance so great that numbers lose their meaning. Yet even that distance, in the grand scheme of the galaxy, is small, a brief span between neighbors. The Milky Way itself stretches 100,000 light-years across, filled with hundreds of billions of stars. Each of those stars has its own space, its own orbit, its own night sky filled with suns unknown to us. From the edge of the solar system, all of this becomes visible not through sight alone, but through awareness. The mind feels the magnitude. The soul senses the continuity. There is no edge to reality. Only layers of light fading into other light. Somewhere out here, the Voyager spacecraft continue their silent flight. Tiny vessels carrying the memory of our world. They have long since crossed the heliopause and now sail through the interstellar medium, each one a small spark in the infinite dark. Their signals, faint and delayed, still reach Earth, a whisper that began decades ago and continues across billions of kilometers. They are our first emissaries to the cosmic night, each carrying a message of who we are. On their golden records are the sounds of our oceans, our birds, our greetings, and our music, fragments of Earth, preserved in metal, moving forever through the stars. Even if they are never found, their journey is enough. They remind us that the desire to reach outward is itself an act of connection. The cosmic night does not feel cold in the way we understand cold. It feels timeless beyond the measure of change. Temperatures here fall to almost absolute zero. But even this number cannot convey the essence of it. In this silence, molecules move slower than thought. Photons stretch into longer and longer waves as the universe expands, carrying the memory of everything that has ever been. It is in this eternal stillness that the cycle of creation begins again. The dust that drifts here may someday be drawn into a newborn nebula, compressed by gravity, ignited into fire. Every atom that floats in this space is waiting to shine again. When you gaze at the night sky from Earth, you are already looking into the cosmic night. The starlight you see has crossed immense distances, passing through the same interstellar medium that surrounds the solar system now. Every glimmer is a reminder that the darkness above is not empty, but filled with journeys. Some of that light left its source before humans existed, before Earth had oceans or forests. Some may come from stars that no longer burn. To look upward is to look backward, in time to see not the present, but the memory of light. The sky, in this way, is an archive, a living record of the universe's unfolding story. At the boundary where the solar system meets the stars, there is no wall, no border to cross. The sun's light simply fades, and the light of others takes its place. The night becomes continuous, a shared silence that belongs to no single star, but to all of them. It is a reminder that the cosmos is not divided, only scaled. The edge of one system is the beginning of another, and between them lies not emptiness, but relationship. Even the space between stars is filled with communication, waves of energy, gravity, and time, weaving them together into a single, luminous whole. As you drift into rest, imagine standing at that boundary, the last soft shimmer of sunlight behind you, the infinite expanse of the galaxy before. The stars around you stretch into every direction, glowing like distant embers scattered across black water. The sun is small now, but its light still reaches you, golden and familiar, a reminder of home. Ahead, countless other stars beckon, their light ancient yet alive. The silence is not lonely, it is serene. You are part of it, as every atom is part of it, born from the same stars, returning eventually to the same sky. The cosmic night is not an ending, but a continuation, the place where the solar system breathes into the galaxy and becomes one with it. And in that eternal stillness, the universe rests, vast, gentle, and awake.